Okay, are you able to hear me?
Yeah, I can hear you.
So shall we start now?
Yes, we can start. I think 47 participants, 35 attendees seem to be there. Yeah. So we can give few more minutes. So if you want, 2-3 minutes.
Okay, we will wait for 2 minutes and then we will start with the prayer.
Yeah. Okay.
So just to check my audio, am I audible?
Yes. No.
Thank you, sir.
Namashvaya Dhanish, am I audible?
Yes, you are audible.
Okay, thank you.
So, okay, we will start the session. We will start with a prayer. So, Deepthi.
Yeah, sure. Namashvaya.
Yeah, we can hear you. Yeah, can start.
Okay. ध्यायामो धवलावगुण्डनवती तेजोमयीं नैष्टकीं स्निग्धापाङ्गविलोकिनीं भगवतीं मन्दस्मितश्रीमुखीं वात्सल्यामृतवर्षिणीं सुमधुरं सङ्कीर्तनालापिनीं श्यामाङ्गीं मधुसिक्तसूक्तिम् अमृतानन्दात्मिकां ईश्वरी.
Okay, thank you, Deepthi. So, hello everyone, and warm welcome to all for today's webinar on 5G local community networks using OpenRAN, IoT and Blockchain for sustainable communities. So, myself, Danish. I'm a research associate at Amrita Vishwavidyapeetham. So, thanks for registering this webinar, and this will be very insightful for all the students and the participants who want to discover and find opportunities in today's key technologies in IoT, OpenRAN, and blockchain, and how this will going to transform into a technological use case for a sustainable community in today's, especially in Indian community. So Amrita Vishwavidyapeetham is the member in one of the member in ORAN Alliance, which stands for Open RAN from India, and we are carrying research towards studying, bringing out different network architectures and use cases for local community networks, and explore private 5G use cases. So today is all about uncovering webinar on the potential in utilizing the combination of 5G network technologies that adopt the best of the key enablers, including OpenRAN, IoT, blockchain, and local community network principles to design and deliver affordable and resilient network connectivity solutions. So before we get started, so I'm going to go through some housekeeping to ensure that you can interact with the presenters. So firstly, if you wish to ask the presenters a question, you have an open chat feature in the Zoom and you can interact with us. So all the questions will be addressed towards the end of the session to save the time. and also smooth running of the webinar. And then we will also launch some Google form towards the end of the session, and we encourage you to fill the form with your valuable responsible when they appear on your chat. Okay. So you can contact any of the panelists in between if you have any issues with the Zoom session. So I would now like to welcome Professor Seduraman Rao, so who is our professor at Amrita Center for Wireless Networks and Application. So he will give a brief overview about our center before we moving towards the webinar. Okay, sir, Sedu sir, so can you?
Yes, thank you, Dhanesh. So welcome to all the participants as well as the presenters. I'm sure you'll have a great afternoon today. So let me start with sharing my screen. Let me open my presentation. All right. So I'll walk you through a brief introduction to our research center. So let us start with the university as a whole, Amrita University or Amrita Peetham. So let me give you some information about the university itself. In terms of the vision and mission, we have like 3 key points. Education for life is, the education that the students get here will definitely enable them to have a great life in terms of all the material pursuits. But in addition, we also give them the values. That's what makes it education for life. So, they're able to lead their life in a wholesome manner because of that. So that's a very important differentiator for us. And secondly, the research we do is compassion driven, thanks to our chancellor, who is a well-known humanitarian all over the world. So any research we do has a direct bearing on the public, on the the problems of the society, and the goal is always to address those problems in a sustainable and meaningful way. And thirdly, the research we do always has a global impact. So not only does it have a positive outcome in India or in the local region where we are, through the various collaborations we have, with the educational institutions as well as industry across the globe, we are able to have this kind of a global impact based on our research. So the university is a multi-campus, multidisciplinary university, and with a lot of focus on research. So currently, there are 6 campuses. Where we are at is known as Amrutapuri. This is near Kollam in Kerala. There is a campus in Bengaluru, Chennai, Coimbatore in Tamil Nadu, also in Kochi in Kerala, and in Mysore as well. And then 2 other campuses are coming up, one in New Delhi and the other one in Amaravati in Andhra Pradesh. So 6 plus 2 coming up very soon, more than 20,000 students, 200 plus programs, 120 plus disciplines, very accomplished faculty. So we are actually ranked number 1 in India for international outlook and international faculty. So as you can see, even today, Professor Seshaya Ponekandi is a faculty at Amrita. He's also leading industry person in at NEC. He's the 5G specialist. So getting a webinar from him is a great opportunity. And all his students, many of his students are also going to take part. So that's another great thing about today's webinar. And again, in terms of research funding, in terms of publications, you can see the numbers there. The other thing I want to emphasize is the number of disciplines that we have at the university. So in terms of the choices, engineering, medicines, arts and sciences, management, and then sustainable development is a very, very key area for us. As a matter of fact, THE, it's a international ranking agency. They came up with ranking based on the United Nations Sustainable Development Goals, SDGs. They call it as the impact ranking. And Amrita was ranked #1 in India and also among the top 100 all over the world in this ranking. So that speaks for our focus on sustainable development, and the research that we do has that as a primary focus. I just mentioned the ranking. There are other rankings that are out here. By the government of India, we were ranked #4, fourth best university overall, and the #1 private university. And same THE also ranked us the #1 private university. We are also one of the institutions of eminence that has been, recognized by the government of India. So, our mission is to reach the top, the top rankings at the world level, at the international level. So many other rankings you can see there. So, overall, it's been a good track record. Now coming to our center, the center is known as the Center for Wireless Networks and Applications. So our approach to research is different, as you will see. Let me go into the details of the center. So what does the center do? It pursues international caliber research. Again, we do this by having that kind of an exposure to international bodies, international institutions, and so on. And the solutions we develop are meant to solve the problems of the society, as I said before. And of course, we use the state-of-the-art technologies for solving these problems. And the teams we have are interdisciplinary because the problems we try to solve are system-level problems. We take to design a complete system to solve a particular problem. So therefore, we need an interdisciplinary team, and that is what we have. And this interdisciplinary team impacts both our research as well as the education that we impart. For programs, we have 3 programs, master's programs, MTech programs. One is wireless networks and applications. You'll get to hear a little bit more about that program today. Again, 4 of the presenters today are actually students who are currently participating in this MTech program at wireless networks, in wireless networks and applications. We also have a MTech program in biomedical instrumentation and signal processing. This is a more recent program compared to wireless networks and applications. Also another program in geoinformatics and earth observation, especially with today with climate change being a big concern and the trust towards sustainability. This becomes very important, and it's a very popular master's program as well. We also have a PhD program and an integrated PhD wherein you can decide to pursue your PhD when you join MTech, and you can customize and optimize your coursework, your research, everything to complete your MTech and PhD in a much shorter time. That's the idea of integrated PhD. We have that option as well. And the interdisciplinary nature you can see on the left-hand side, the different areas in which you have expertise. It ranges all the way from wireless, physics, geology, data science, machine learning, electrical, electronics, mechanical. We have faculty with all these expertise, interdisciplinary. A lot of adjunct professors from across the globe, which adds to our overall team of expertise. So a lot of courses are actually taught by adjunct professors. We have 26 PhD scholars. So the MTech theses, quite often, they get co-guided by international faculty. We also have options for dual masters. We have option for joint PhD, wherein there is also an option for a dual PhD, where you get a PhD from Amrita as well as an international institution. You can also have co-advisors from international institutions for your PhD, research. Student exchange programs, quite a lot of them. And then a quick mention about this program called Live-in Labs. So as the name suggests, this is where our students, along with students from other institutions across the globe, they get to go to the different villages that we have adopted, 108 villages in different states of India. So you go there, you get to understand the challenges faced by the villagers. Then you get to devise solutions to address those challenges and implement them. So it's a very challenging, very exciting program with a lot of participation. In terms of the various technology domains we cover, especially in wireless networks and applications, you can see the whole spectrum there. It's very, very rich. Mobile networks, we get to hear more about that today. Especially when it comes to private networks. Internet of Things, machine learning, SD and NFV, big data, wireless sensors, you name it, virtual reality, augmented reality, and object-oriented programming is given a lot of importance, etc. I don't want to go through cloud computing, edge computing, all these things are very important. Blockchains and distributed ledgers. So in terms of, what do the students get to do after they finish their coursework? They have job opportunities in various domains, as you can see, whether it's manufacturing, automated production, 5G, of course, e-commerce, digital services, online education, pharma, drug, right? So AI, ML has applications everywhere today, as you know, robots, drones. So, this whole 5G, as again, you will hear more about today, it is getting everything together and integrating things nicely. So it opens up a lot of opportunities in what we call Industry 4.0. So these are just some verticals that have been mentioned here: healthcare, e-commerce, robotics, IoT devices, cloud computing. This is just a representative sampling, not the whole list. In terms of the faculty, Dr. Manisha Ramesh is our director, and the key thing I want to mention is that she has been recognized as being in the top 2% of the scientists in the world by a recent study by the Stanford University. This was conducted about 6 months ago. And she also heads the UNESCO Chair for Experiential Learning for Sustainable Innovation and Development. So the Live-in Labs program I talked about, it fits into this UNESCO Chair position very well. And she's also in the advisory committee for the Kerala State Disaster Management Agency. Again, a lot of different varied research interests. I don't want to go into all those, good record with publications, patents. Professor Menon comes from the industry. He was with DRDO with a lot of, background in underwater communication, sensor development, sonars. Professor Balaji Hariharan has US experience in a couple of decades in the US before he joined us. Setu Raman Rao is me. I too have been in the US for a couple of decades before I joined Amrita about 9 years ago. Dr. Vadhavan was the former Director General of GSI, so the geoinformatics, and he has a big role to play in that program of ours. Dr. Ravi Shankar with a lot of experience from QSAT. And some of these people here, they're all, our own product in a sense. Some of them did their MTech here and went on to do their PhD and have become our faculty. And these were the cream of the crop, so to say. And they decided to be with us because they were so excited with the work we do here in terms of our research. So that speaks volumes about what we are. We also have faculty who have joined us, young faculty with international exposure, international experience. Dr. Martin comes from Germany. He's a PhD from Kaiserslautern in Germany. Dr. Alka Singh comes from TU Munich, Tech University of Munich. And she's also done her postdoc at NASA, a couple of them. So, Dr. Dhanya is part of the GEO team again. Dr. Ramkumar is into augmented reality, So again, you can see the list of adjunct faculty here. Again, you will see that there are people from across the globe. Dr. Asia at the top of the list. Dr. Nagabhushana from Qualcomm, USA. Dr. Prasant Mohapatra, who's from UC Davis, USA. Martin from Netherlands, and so on. Dilip from GEO, industry exposure. Dr. Bhatkar, Dr. Fujita from Japan, and so on, right? So you can see the varied exposure you get to different people with different backgrounds. In terms of our placement record and internship record, and when we talk about internship, the MTech students, many of them typically get to do their internship during the second year of their study. It's a 2-year program. So quite a few do it during the entire second year, and quite a few others do it during the last semester, 6 months. So there is a lot of opportunities for doing internship, and more often than not, the internships get converted into a full-time job opportunity at the end of the period. So the companies, again, you will see there are product companies, there are IT companies, there are startup companies. You have the whole mix there. There are also some educational institutions where people choose to go after they finish because they want to be in the academic field. So there is a lot of international opportunity, like I mentioned before. These are some of the universities we collaborate with in the US, in Europe, UTH, Colorado State, Trento, in UC Davis, Amsterdam, Munich, and then quite a few of them also offer the option of a dual degree by which you spend the same 2 years, 1 year at Amrita, 1 year at the other university, and you end up getting 2 master's degrees, one from Amrita and one from the partner university. That's also a very exciting program. Many people opt for that. Yeah, so, in terms of what are the possibilities for you when you are doing your studies here, you do get to write journal papers, you get to file patents. So 50% of the total number of patents we have come from the work done by our students. The international experience, dual degree, like I said, integrated PhD, dual PhD also. And there is a lot of, scope for industry engagement, also engagement with the research institutions, both national and international. So in fact, there are students currently at the Berkeley labs doing their internship, the British Geological Survey. So a lot of these institutions partner with us and they do offer opportunities for the students. In terms of the centers, initiation and growth, we got started in 2006, and the first project we did was a landslide early warning project. And one thing about our projects is that there is always a deployment associated with it. It's not just a theoretical project. It's not something that wherein you do some simulations, develop some algorithms, results and be done with it. No, so this is the EU, European Union funded project way back in 2007. And right from then, our focus has been on deployment. And so we do have a landslide monitoring system deployed in Munnar in Kerala, which has been operational for the past 12 plus years, issuing many warnings during the monsoon seasons. And that helps to evacuate the residents of that area. And once the rains abate and the warning has been lifted, they come back and continue with their livelihood. Otherwise, previously they had to, proactively or preventively evacuate every monsoon season for the fear of landslides. So that has been avoided now. And subsequently, we got further funding from the Ministry of Earth Sciences, and we have another system, slightly bigger system for monitoring landslides installed in Sikkim near Gangtok. So that has also happened. So first system in Western Ghats, second system in Sikkim in the foothills of the Himalayas. And then we also have some, projects in the area of wearable medical devices. So the ECG monitoring device, which was launched by our Prime Minister in 2013. We also have another project, another one of our major projects is known as the OceanNet, which is to provide a very affordable internet connectivity to fishermen. So this was again launched by one of the union ministers in 2016. And we are the World Center of Excellence for Landslide Disaster Reduction. That's a great recognition for us, and so on, right? So many other recognitions. And so we've had a great record, I should say. A lot of representations in international conferences, international events, etc. And even during the COVID times, our research has resulted in a lot of innovative outcomes, which have been deployed at our hospital in Kochi. The Kochi campus is a medical campus, so there is a medical, college as well as a research, activities, and a medical hospital also, attached to that campus. So that's where many of our medical-related research gets field. In terms of the research we do, we can kind of categorize them into 4 different, headings. IoT for extreme environments, wearable medical systems, smart city infrastructure, and immersive learning. And so let me just go into the details of each of these a little bit. So when we talk about IoT for extreme environments, that's where we talk about landslide early warning and flood monitoring. So we had floods in Kerala, as you know, both in 2018 and 2019. So the apps and the systems we developed were extensively used to save a lot of lives during these floods. We had a 24/7 call center managed by our students and staff during these floods, and using our apps, crowdsourcing apps, a lot of good work was done. I talked about the offshore communication system for fishermen, that is like affordable internet for them. And then there is also a multi-hazard related research where, one hazard leads to another hazard to another hazard. So there is like a link between different hazards. For example, when there's a lot of rainfall leading to flooding, it could in turn cause landslides. It would cause, rock slides and so on. So, those kind of related multi-hazards are also being studied. In terms of wearable medical systems, We have a ECG monitoring system called Amrita Spandanam, which I talked about before. We also have multi-parameter vitals monitoring, for the ICU patients. A lot of imaging activity going on, image processing, based on computer vision, so breast cancer detection using thermograms and histopathology. There is also remote patient monitoring in the COVID-19 context, in which there has been a lot of research and output as well. Coming to smart infrastructure, smart city infrastructure, we have smart grid distribution network. This project called Stabilize E is an Indo-European project. So many of our projects are actually collaborative. They are like Indo with some other country or continent like Europe. So that's the nature of many of our projects. So we have renewable energy projects, which are again deployed in some of the villages we have adopted. So we have labs also to test out different algorithms, different setups, configurations. There is also a lot of water research, water-related research in terms of water distribution, water purification, etc. There's a project called Forward, which is again a collaborative project, Indo-European. In terms of immersive learning, this again becomes very relevant in today's context when remote learning has become the norm these days. So when you do remote learning, how do you make it more immersive? So we have done a lot of research there. So to establish eye contact between the students and the teacher, as well as between students in different locations in a very realistic, real life manner. So that's where by using multiple cameras and microphones, and using algorithms to choose the best options and so on, we have created this kind of an immersive learning environment. The other aspect with respect to that area is the AR-based heritage site reconstruction. A lot of heritage sites have been, destroyed either due to wear and tear or due to some invasions. So if you can use augmented reality to reconstruct those sites to appear as they were in their original pristine, greatness, that would be a wonderful thing. And that's what we are working on here. And so a lot of words first, I talked about this early warning of landslides. I won't play the video because I think we'll move on to the webinar itself. This is the an offshore communication platform. Again, this is a world's first at that kind of a cost point for the price point for the fishermen. We don't have such affordable solutions today. Then a lot of laboratories, Landslide Laboratory, where we simulate landslides, wearable IoT monitor. Amrita Kripa is the flood relief app that I mentioned. And there are a lot of remote laboratories also for other people to use. So I mentioned that a lot of our projects are international. So you can see that Indo-German, Indo-Brazil, Indo-Japanese, Indo-Italian, and so on. We also have joint research centers that we have set up with the BGS, Milano, and so many other such institutions. And we have a number of research partners. I'm pretty sure this is not the exhaustive list of all the research partners that we have. Sampling again. Some numbers, I wouldn't go into the details, but just suffice it to say that we got a good, very good record in terms of high impact publications, in terms of the just sheer number of publications and so on. And like I said before, 10 patents, US patents, have been granted based on the work of our students. So that's an important aspect that I would like to emphasize here. So the average is also pretty good in terms of per PhD graduate average, per faculty average for publications and so on. Yeah, so like I said, out of 20 US patents that our center has, 10 have been from the work of the students, and some of these have been productized. So as you can see, 6 of them are in the process of getting productized. So we partner with some industry and then take it to a product. That's also part of our work. So some other numbers you can see in terms of funding, partners, etc. The recognition as World Center of Excellence on Landslide Disaster Reduction by the IPL. I don't remember what it stands for, but this is the international body that gave us this recognition. And even at the national level, we had the NABARD award for this rural innovations, and then special mention in the Parliament by the Prime Minister, and so on. So quick mention of the COVID-19 related research and interventions. So again, remote ICU bedside monitoring, a very innovative way of doing it using a smartphone and also a remote IoT based bedside monitoring, which monitors various vitals for the patients, because this whole remote monitoring becomes very important for the COVID-19 patients, as you know. The Live-in Labs program that I mentioned before, so 108 villages have been adopted. So various areas like agriculture, education, energy and environment, water, sanitation, health and hygiene, waste management. So these are different, themes or different domains where we work to solve the real problems that the villages face. Go to a specific village, understand what their needs are, and try to address that. And our students and the students of our partner institutions across the globe are actually involved in these projects. So, like I said, internship is very much a part of our MTech programs, and we can give you more details of that if you're interested here. We can also give you more details of our educational programs, also the master's programs, the PhD programs, the integrated programs, and so on. Feel free to contact us, and we'll be happy to provide you with more information. So with that, I'll end my presentation on this note of compassion-driven research again. So among the three key points I mentioned, this is like the center, the most important one for us. Again, inspired by our chancellor, popularly known as Amma, across the globe. So compassion forms like the glue that connects all of our activities together. Thank you so much, and I'll let Dhanesh take over, and then we'll move on to the.
Thank you, Seri sir, for your presentation and introducing our center and its program, facilities, highlights of our research areas, and faculties who guide our students. So now I would like to welcome our presenters for the webinar. So first I will welcome Dr. Sheshaya Pannakandi, who is Adjunct Faculty of Amrita Vishwavidyapeetham and Career Solution Manager and 5G Solution Architect at NEC, UK. So who always loves to guide our Amrita student research community with his wide experience. Now I welcome Srilashmi S. and Mujtaba Inayati, our research scholars who are working in the area of OpenRAN. And importantly, I also want to welcome our graduate students of Amrita WNA, Parvati SS, Prabhu Magaran Mila, Rahul KP, and Tom Toby. So I'm glad that the students are the key drivers of this webinar today, under the guidance of Sheshaya sir, to share all your insights and learnings on 5G local community networks. Floor is yours, sir and team. Thank you.
Thank you very much, Professor Setu, for introducing. First of all, thanks everyone who joined. Nearly, we are looking at 70 participants. We are ever so thankful to all of you to join this call and share our knowledge that we have in this area. So, thank you, Dhanesh, for running these agenda items. So to start with, we would like to, I would talk a little bit about the sustainability. Before I start my talk, I would like to invite one of the special guests here. Her name is Lakshmi Rajagopal. We are proud of our alumni here because Lakshmi has recently, after completing MTech at WNA, Lakshmi has recently secured a job opportunity in the UK with British Telecom Laboratories. So Lakshmi, please, can you share your thoughts or your experience on the WNA?
Thank you, sir. Hi, everyone. Am I audible?
Yes, Lakshmi, I can hear you.
I just prepared a small presentation. I will share that too. Okay, is my screen visible?
Yeah, you can go to the slideshow. Yeah.
Yeah. Hi, everyone. I'm a familiar face to some of you. I don't know like who all would have seen me otherwise. Currently, I'm working with British Telecoms and I'm doing my PhD also. I work in their research labs located at Adastral Park, Ipswich. I joined here last March and it has just been a couple of my months in my journey. I would like to express myself on how I developed as a person, both career-wise and professionally while I was at Amrita. The three figures that I've just shown here just represents me as myself on how I grew over the years, like from my high school to my undergraduate, after that my master's in Amrita. So like everyone, I just completed my high school in the year 2012 with basic knowledge in science and mathematics. After that, I chose to join engineering in electronics and communication engineering in University of Kerala. And when I came out of there, I just had a few theoretical knowledge and some lab expertise, and I was like, okay, how should I step into the world? And I didn't know how the industry works also. So I felt, okay, the knowledge in me was insufficient, and that's the main reason that drove me to take a MTech. And why I chose Amrita, the initial attraction for me was the OceanNet project, and that's what actually attracted me towards Amrita. And I should say the courses that was offered there was in a structural manner, because at the initial year or the initial semester, we all had like fundamental courses, which was really important because a good base or foundation has to be there onto which you have to like build upon your technological domain or technological knowledge. So that if like in the initial year, we had courses on programming, fundamentals of wireless communication, etc. Then signal processing, all these like had to lay a very good foundation. And on top of that, other technological courses started building up. That was the point where I started deviating myself into 5G. Before that, I have only heard of these terms, but I didn't have much technological domain or background behind that. The course that was offered by Dr. Sheshia Punikanti on mobile communication networks, as well as 4G mobile broadband and small cell networks, that was the prime factor that drove me into this technology world. I was really fascinated by all those technical words, like words like SDN, NFV, MEG. I still remember, like we had a use case modeling that was like we were asked to identify different use cases that were relevant with 5G, and we all came up with different use cases like digital enterprise, smart hospitals, smart homes, etc. And the way like we understood everything, it was like we didn't come across 5G at once. It was in a hierarchical manner, like 2G, 3G, 4G, 5G, and we were like visualizing like how these things would be in 4G, and we were learning about the technologies in 5G, and converting them from 4G to 5G actually gave a really depth understanding on how this technology layout was. And these two were the prime main things that drove me towards this technological world, because wherever I go, like nowadays, everyone is talking about 5G and everyone only speaks about technologies. That's what really fascinated me. And the more you talk about technologies, the more you will be driven into it, because I always feel it like a magical world. And apart from that, other courses like on design and analysis of algorithms and machine learning were like other supportive pillars that helped us like to talk about or visualize many things easily, because in current world everything is becoming virtualized and everything is becoming smart. So basic concepts of these things are really important for you to come out of yourself and see what's going on outside there. And my major achievement onto this position was because of my project, which I had done on synchronization. I should really thank Sir for actually putting me into that part. I never knew, like, okay, this was a fascinating topic and it's going to be a like a hot topic over the coming years. When I took that, I was not really aware of that. But as soon as I started progressing, and I often hear nowadays from my manager telling me that, oh, I don't know, how come you took this topic? It's very rare to find people who have knowledge in this domain, and you are trying to pursue your career in this. And he has told me, like, I'm one among hundreds. It's really some golden words which we always love to hear in our career. And I should say that Amrita is the base, and the WNA courses that I got there was the base for everything. Other exposures, like as Setu sir has said, the conferences and internships. Internships are like very important, because whatever you learn in your technical, you have to see how it works in the outside world. So the internship actually helped me to correlate my theoretical knowledge with whatever practical world or practical solutions I came across. And I got internship at Toshiba on my second year of my MTech course, and over 1 year I was doing internship there, after which I got a job offer there, and later I moved on to my PhD part. And the conferences, whatever you get there, just pick it up, try to do your research and publications, because when you talk to public, you always get a more exposure to express yourself as well as make contacts, which will obviously be helpful for you in the coming future. And at Amrita, you have a lot of opportunities for that, and just explore. I hope everyone was clear, and thank you, Amrita, for the opportunity. Thank you, sir.
Thank you so much, Lakshmi. We are delighted to have you here among us to celebrate your success, yeah, and also stepping into proper industry research. Yeah? And so,
yes, sir.
Thank you for your time. Now, the next item in the agenda is. I will set the scene, and we will step into the webinar itself now. So without much delay, I will try to take you to the presentation of the webinar. Where is the? So today, the topic that we are interested is the sustainability. And I'm just trying to update you on actually what sustainability means. Yeah. I should be sharing the screen now. Please just give me a sound if you're able to see my slide. Yeah.
Yes, sir.
Ganesh, are you able to
Yes,
see?
sir.
Yes, sir. Yes, sir. You are able to see.
Okay, thank you. So there is technology is changing very rapidly, but more recently, there is a big recognition in the technology and also policymakers throughout the world that the technology has been going too far away from the usage itself. Who is going to be using this? Yeah, so majority of the people, as in the later presentation you will see, they don't have connectivity. Yeah. So now, and also technologies have become too much resource intensive. Yeah, the natural resources have been depleting, and the technologies have been consuming too much resources. So sustainability has become one of the main research items that is going to go hand in hand with the technology development. So to see the mix of these things happening now, we have put together a few points for you. One of the key items is the energy efficiency. Yeah. All the technologies now need to be considering energy efficiency. If you go back to the topic of the webinar, we are talking for 5G and also evolution to the 5G. Almost all the protocols and all the wireless air interface processors are going to embed new signaling procedures, new types of retransmissions, so that energy efficiency becomes central to this. At the same time, the networks are being softwareized, and a lot of hardware, software has been put into the data centers. These data centers are consuming a lot of energy. So that also is an item of great interest now in the research, and there is a lot of work going on. In fact, Google recently has made announcements to move some of their data center locations to more energy efficient places, take the data centers closer and try to make use this concept of energy efficiency. To be able to bring these technologies that become energy efficient, really there has to be different approach in the way networks have to work. And to make that approach, we see that contracts are going to be very important. So we bring in the idea of the smart contracts going forward. And these smart contracts are going to provide deployment of these networks. And the deployment is normally like Wi-Fi. At the moment, to deploy Wi-Fi, we do not need any permission. But to deploy wireless networks in the cellular frequencies, there is a requirement to get permissions. So we will see that from unlicensed, which has been very successful, Wi-Fi, we will move into network operators keep on working in a licensed spectrum, but there is an intermediate option that is emerging that is called lightly licensed, where license fee will be very small. And then 5G networks can be deployed by various organizations. We will cover that part, and we will try to explore if such sharing has to happen of the frequencies, what is the agreements required. We will try to show the framework in the coming presentation details. Now, once these frequencies are identified, then comes how to cloudify the network functions and how to have tools that are not so hard to develop. Telecom industry has been working for dozens of decades to develop with network monitoring tools, network measuring things. But increasingly, open source technologies have resulted in quick solutions. So new people, new entrants into the play can download these open source tools and start understanding the network management, performance evaluation, and those kind of things. Now, on the research side, we need to understand into a big thing called cooperative networking. How can new networks and old networks exist? How can networks that are lightly licensed or private networks and the public networks work together? To support this idea, the research is now intensely going on extending the machine learning to distributed machine learning running at various data centers. Yeah. So this will support using the spectrum on demand. Once the spectrum is unlocked, the deployment becomes very easy. That is why some people are looking into the policy side of it, and they call it as democratized spectrum. I mean, spectrum can be given to various parties, and there has to be some etiquette, and there has to be some AI-based monitoring of this usage of the spectrum as well. And the big point that comes is the privacy. In the previous generations, the mobile apps and various other technologies somehow could not preserve or could not protect the privacy of the users. End users' data has been used and has been commoditized by various people in the from the internet world. Now, due to recent cybersecurity threats and also various other citizen rights coming into the picture, privacy has become one of the important parts. Otherwise, the technology cannot be sustained if we are not preserving the citizen rights. Yeah. So research into privacy and also trying to protect the data, use all the technologies to provide privacy support in the network. Yeah. And then once the privacy is achieved, is it possible for giving people some share of their data? At the moment, the data is taken from the web transactions and app transactions, and the providers are using the data to commoditize themselves. The end user is not getting benefited at all. They are just getting to use the app and the web. So some of this data and the utilization of the data, the model has to be changed to make it sustainable, so that everybody becomes a stakeholder in accessing the revenues that are coming. So in the new era where sustainable communication, sustainable networks become main communication theme, data ownership would be another item. So, and then local languages and trying to provide microfinancing and also some kind of a small traders having their very simple user interfaces and able to communicate without overly using apps and advanced devices. So a sustainable research has many dimensions. Only some of them here are concerned. So where are we now in terms of industry? Yeah, we try to capture here few trends on it. So if we start from the left-hand side, one of the most important thing that is happening now is networks are usually sourced by one supplier. Yeah? And this has now changed. Yeah, there will be several suppliers providing networking functions as softwares. So in fact, the entire network or the infrastructure is becoming as a code. That means it's becoming programmable software. You will hear more about it later on. So in general, the three components started playing a bigger role in making the networks interoperable and multi-vendor based. Yeah. Telecom core network in the 5G has dramatically changed. Yeah, it has taken the concept of distributed components. It has grown from the virtualization, and it has absorbed IT model, where you use microservices and serverless architectures and DevOps framework on the top of it. So now the core network becomes a simple softwareized APIs can call these network functions and borrow that particular network function they want. So now once the infrastructure gets cloudified, the second point that becomes important is what is happening at the cell towers. Yeah. So now the cell towers are owned by network operators. And the network operators traditionally have been buying mobile base stations from different companies. Yeah. So this is the area where rapid advances are taking place, and these base stations are now getting disaggregated. That means they are also becoming software and hardware separated. And then this combines with the trend to put some of the functions in that into a cloud. So some of the less delay critical things like control plane functions in the radio access network can be put in the cloud. And only just antennas, the big tower and the cabinet you see underneath will disappear. It may exist for the legacy, but in the future, we will start looking into a very small, compact base stations, mostly antenna and with a limited software capability on it. The rest of it is done on a different sites, depending on the application that we are supporting. So this disaggregation of the networks based on some cloud native principles brings this entire management into a new era. Why the management has changed? Because the cloud players like Amazon and Microsoft with Azure and Google, they have actually got into telecommunication core network, and they started offering instances that can be downloaded as workloads to create a network. So from a physical network which was deployed and slowly change. Now we come to a situation where the network can be deployed on the demand with cloud workloads. So this management of that is very important too. So these three parts are actually, each of them are rapidly evolving in the current way. To the previous object of sustainability, they become very important. Now these are supported by some additional building blocks. One of them is automation itself. The cost has to be low and the manual intervention has to be reduced. So the networks have to self-configure, self-manage, and self-heal to troubleshoot themselves, to be able to prevent the outage and provide very good qualities of service in terms of data rates, latency. So network resource management is now become AI ML based techniques. Using these advances, there is now an opportunity to start deploying small networks that are dedicated for one application. For example, if a campus needs a different type of network, we can go ahead and put a 5G campus configuration there, dedicated to the students and the staff and the various other R&D laboratories, sensors, and various things involved in it. So the beauty of this research is now there is a lot of effort ongoing to make it as simple as a Wi-Fi deployment. Yeah, to deploy a network, it is taking sometimes 3 to 6 months in a new campus or a new network by a telecom operator because of a lot of regulations and a lot of procedures, planning involved in it. But in the private networking era, some companies are claiming to do it in few weeks. And IT managers can actually deploy these things. So one-click deployment is the target here. So if these are falling into place, these 5 parts, then I think there is a good foundation to a sustainable 6G network. And there is a lot of discussion, and icon I have deliberately taken it to be green because the energy consumption has to be brought down. And there's a lot of work happening on that. For example, the data centers need a lot of cooling. In Denmark, these data centers sometimes are put near the wind farms. Yeah. Sometimes there is a capture and sometimes there is the gases from the greenhouse are captured, the heat temperature wise, and they are hot and they are providing to keep the data center warm enough, hot enough. So these kind of circular mechanisms to manage the heating and the cooling requirements of the data centers, which is very energy consuming, and also reducing the towers and conforming with the day-to-day life aspects of digital footprints from various aspects, carbon footprint, pollution footprint, IT hardware, making it leaner and trying to deploy according to the requirements, use virtualization techniques. These things are the fundamentals of the 6G, and I would like to highlight here that these 5 items are independently, a lot of research is going on to input into that, and in the right time 6G discussion is also happening. So rest of the webinar we will take it down to ground up approach. How are we, some of the students working in this area, how are they trying to come up with system design and also some kind of case study work and trying to put some kind of reference model, and then identify the tools and build the lab based on those tools and put together end-to-end test bed. So our approach is to understand the bigger picture in the sustainability landscape and start from the ground up to test simple things. We have done various conference papers to show that you can go from bottom up to evaluate these techniques. So the important point that comes, which is not covered here, is the blockchain. Yeah. But before we go to blockchain, I just want to quickly cover that private networks, which can be deployed by anybody in a smart campus situation, the university can deploy it. Yeah. In a smart city, the government, the municipality can deploy it. In an airline industry, a particular airlines can deploy, an airport can deploy it. So these are all private networks which are becoming very much integral now to the way networks will be deployed in the future. So you can see here that the growth that is expected is 66% of compound annual growth from 2019 to 2025. Yeah. So different sectors can use these private networks, and you can read it here, ranging from healthcare to gas, electricity, manufacturing, automotive, all these. So we would like to highlight that we believe towards the sustainability, private networks will become integral to that. So final point is the second, apart from the private networks, we also see blockchain playing a crucial role. Yeah, we have a detailed presentation about blockchain, but here I just want to point to you that blockchain is building upon the traditional software as a service model in the IT world, move towards platform as a service, yeah, where you get today a lot of platforms are providing services. Then this one has been taken by the telecom concepts, and we are now looking at implementations called mobile edge computing infrastructure as a service, IaaS. Now, by combining here the smart contract capability at the storage level, at the transaction level, at the data preservance level, all those levels, by taking the blockchain, we can realize mobile edge computing blockchain platform. Yeah, we just evolved this into mobile edge computing blockchain. And this will underpin what is the theme of this webinar, the local community network service management. How do we manage the end-to-end service in local community networks, which are deployed like a private network by different stakeholders, like I said, universities or NGOs for disaster relief, or fire departments can deploy their own. So there is a lot to come here, and of course, we are working in the reference design stage. We will point you to various elements. A lot of technical elements come into this picture. We hope all of you enjoy the rest of the presentation. And towards the end of the presentation, we also give some examples of how current students are onboarded into these advanced technologies. Yeah, many of them do not know much about 5G, but they have taken the relevant courses, and then they were onboarded into 5G, and they are rapidly trying to acquire these skills because industry demands these skills now. There's a shortage of skills in this area. So once again, thank you very much for all of you for joining this webinar. And I would like to invite the first presenter, Sri Lakshmi, to take the floor, yeah, and start the presentation, please.
Thank you, sir.
I need to, can you take it, or do I need to stop sharing somewhere?
Yes, sir. So you need to stop sharing for me to share the screen.
Okay, okay, yeah, I think somewhere I need to come up with that option. Yeah, please go ahead.
Thank you, sir.
Thank you. Please go ahead.
Good evening, everyone. I hope all of you are safe and doing well. My name is Sri Lakshmi. I'm currently pursuing PhD at Center for Wireless Networks and Applications. My research area is emergency services in 5G networks. So I thank my professors, Dr. Sheshia Pannakanti sir, Dr. Manisha ma'am, and Professor Sethu sir for giving me an opportunity to deliver the talk on 5G local community networks using OpenRAN, IoT and Blockchain for sustainable communities. So before going into the details why we are focusing on the sustainable communities, let us understand the digital divide that exists between the rural and the urban communities, especially in developing countries like India. So currently the world is witnessing rapid advancements in mobile communication technologies or wireless internet connectivity, where all categories of devices and things would be connected seamlessly at any time or place. That is, as an end user, our ultimate demand is that we should get connected to the network. We should stay connected and reachable at all the times to enjoy the services. And it is evident that this rapid growth in the wireless internet access, it has brought significant advancements in industrialization, especially accelerating the economic enhancements in metropolitan cities or urban communities. But the situation is different in these rural areas. This is because largely unconnected and underprivileged rural communities exist, which generate a digital split between the urban and the rural communities. And during this lockdown, COVID-19 lockdown, it highlights India's greatest digital divide. Because despite the rise in the wireless users every year, the rural and the urban India, they are miles apart on their online presence. For example, if we during this countrywide lockdown scenario, the government has decided to hold online classes for the education department. And if we focus different village or rural areas in different parts of the country, we can say that some of the parents cannot afford even to buy a smartphone for their kids to attend the online classes. Or in case if they can afford to buy a smartphone, they do not have adequate power supply in their region to charge it or an efficient connectivity infrastructure that can enable services to them. So this education area or education sector is just one area that highlights the digital divide during the lockdown scenario. The trend is evident everywhere, not only in the education sector, in the banking sector, in the healthcare or telemedicine area, e-governance, e-commerce, all of these become accessible only via wireless internet connectivity during the lockdown period. And if we park this lockdown scenario, and if we focus into other rural communities or local communities like the coastal communities, the fishermen, the people who rely completely on fishing or low-income small marine trades for their survival, they have to travel kilometers away from the shore in search of the potential fishing zones. However, due to the lack of an efficient connectivity infrastructure, they do not get the news of a disaster event or they cannot communicate during an emergency scenario. Overall, we can say that there is a large population on one side of this digital divide, lacking access to a technology which is widely considered as a fundamental right. So how we can overcome this digital divide, or what are the key solutions that can close this digital divide? Actually, the gap between these rural and urban communities is primarily due to the lack of interest of the mobile network operators to deploy infrastructure in low return investment areas. We can observe that in developing countries, these mobile network operators, they tend to upgrade their networks in urban areas or metropolitan cities. And new technologies are less likely to be deployed in rural areas due to the lack of this business growth or low returns on the investment. So what are the key requirements that can solve this problem? One is affordability, that is inexpensiveness. Second, interoperability with mobile networks, that is readily to connect and exchange the information. And sustainability, which should focus on three dimensions, that is socio-economic and environmental benefit. So many advancements have been coming in mobile communication technology, and with the advent of this 5G cellular technology, it accelerates the digitization of economies and humanity. So this webinar explores the potential of the 5G architectural advancements and local community network principles that can develop a reference design of a resilient, reliable, and affordable connectivity infrastructure, especially focusing the rural communities. And the technical design details the 5G open radio access network, private network deployments, and blockchain technologies. So before understanding the key techniques that can realize a sustainable infrastructure, it is necessary to understand what is a local community network and how it is different from a public mobile network. So currently, public mobile network operators like Jio, Airtel, or Vodafone, they deploy public cellular networks like 4G LTE. A licensed spectrum, which is offered by regulatory bodies like TRAI, Telecom Regulatory Authority of India, will be used by these mobile operators to deploy the cellular network and provide data or voice services from base stations covering a large geographical area. However, such network deployments, they are time consuming, and the process to extend or expand such deployment is very expensive. Local community networks, on the other hand, they can be deployed as dedicated local networks with small access points or compact access points, forming the private cellular network, or known as the non-public network. And the peculiarity of this private network is that they can be operated using a combination of licensed, unlicensed, and shared spectrum like CBRS and multi-fi technology to boost the deployment for better experience. And it is also not necessary that this private network should be deployed and the services should be delivered relying on a mobile network operator. These non-public networks, they can allow the LCN or the local community network providers to set up their own network and provide services to the communities. And during this COVID-19 scenario, the requirement of connectivity has increased dramatically. So government and regulatory bodies, they were exploring policies like spectrum sharing and licensing to facilitate the deployment of this non-public network or the private network, which is paving the way for this local community network. Who can be the provider of this local community network, or who can be the owner of this local community network? They can be potentially deployed by end user community like utilities, oil or gas or water, then enterprises, hospitals, or shopping mall owners, then local government councils or non-government organizations. So actually, this is accompanying another parallel initiative to realize the sustainable network. So what are the sustainable development goals? So mainly the aim is to provide affordable connectivity to every people in every part of the country in order to sustain the progress of the world. So this is achieved by the private, public, and social sectors to come into global partnership for the technology and infrastructure upgradation in order to provide sustainable and modern services to the communities. And 5G network is seen as a high capacity backbone for providing rural connectivity. And beyond 5G, research is going on in 6G, which is seen as an enabler for affordable and sustainable infrastructure technologies. And there are also some prominent global projects and initiatives that is happening around in the world to realize the sustainable infrastructure and to extend the rural coverage. For example, India's Wi-Fi Access Network Interface or WANI scheme. It is a public Wi-Fi scheme enabling low-cost Wi-Fi hotspot services in large number. And another is the Facebook Tips OpenRAN project, which works together with Eventstar and other industry players to quickly deploy a flexible and scalable infrastructure, extending the rural coverage. And as I explained in a local community network, that they are deployed by communities. So they need some sharing models with the mobile network infrastructure. So projects like Amber Internet, they try to create blockchain-based platform to enable and incentivize users to share the internet connectivity over Wi-Fi with others. So the objective of all these initiatives or the program or the projects is to realize affordable connectivity for all. Understanding the societal needs of these rural communities and the sustainable development goals, there are some key enabling technologies that can be connected together to realize a sustainable infrastructure for local community network. That is the 5G, a service-based architecture or the standalone architecture, network slicing principles which create multiple logical networks on a shared physical infrastructure. And this helps the local community network to effectively utilize the mobile network infrastructure. An open radio access network, which migrates towards a virtualized data centers concept by shifting some RAN functionalities to the cloud. And IoT platforms, which help in live traffic information, smart agriculture, public safety or water quality management in rural areas. And recently, cloud companies, including Google, Amazon, Microsoft, they have developed IoT platforms based on legacy IoT solutions. And in future, it will be migrating towards the 5G technologies. Then comes the synchronization, which is very much important for emergency services because precision timing requirements are critical to maintain between the network entities to support emergency services with maximum accuracy. Then comes one of the key enabler, that is the blockchain, which will be discussed in detail during this session by my colleague. So 5G service-based architecture. Why it is known as a service-based architecture and how it is different from the current network architecture. So current network architecture, they are static and architected using purpose-built hardware. However, the 5G architectures, they become diverse and are composable architecture that can transform based on the network usage. And this is achieved by utilizing the software-defined networking, SDN, and network function virtualization, NFV principles. That is, the architecture becomes agile, flexible, and scalable with the software-defined infrastructure. In 5G, the network elements will be softwareized and they act as network functions, making the architecture highly programmable and dynamic. And network function virtualization, it replaces the network services such as load balancing or routing or firewall, which are delivered by dedicated hardware with softwareized functions, making it more flexible. So the key parts of a 5G service-based architecture is the user equipment UE and the air interface, which is known as 5G NR. It's a scalable air interface because 5G is meant to support diverse use cases such as enhanced mobile broadband, ultra reliable low latency communication, and massive machine type communication, which need to address a wide categories of devices ranging from tiny IoT sensors to high-end devices like smartphones or machines or drones, vehicles, robots, etc. So to support such variety or different categories of devices, the air interface is scalable, supporting multiple bandwidths, multiple spectrum for the service deployment. Then comes the next generation radio access network consisting of the 5G base station known as the G Node B. And in a mobile communication network, the key concept is to make the users join the network and also exchange the packet between the users and the network. So the concept is realized by two important transactions, that is control plane and user plane. And control plane is responsible for the call setup or the session setup, maintenance, termination, and providing the quality of service. And user plane is responsible for the actual transfer of the payload or the user traffic. So in 5G, there is a control plane function group and a separate user plane function. The user plane function is responsible for the packet forwarding and routing towards the data network. And in the control plane function group, there is functionalities like network functions like access and mobility management function, which is responsible for the connection and reachability management, session management function SMF, which controls the UPF for the packet forwarding and also determines the policies and charges that can be applied for the services. Then comes the policy control function PCF, which support the 5G quality of service policies. Then user data management, which stores the subscriber details and the management of the subscription profile. In the case of this 5G SBA or 5G architecture, the insight into the various application requirements or the application environment is enabled by the network slicing concept. So there is a network slice selection function known as NSSF, which select the appropriate network slice instances to serve the particular user. Every slice will have its own slice ID and particular instances can be selected to serve the user requirements. Then there's a network repository function NRF, which stores the network function profiles and network function instances available and helps in the service registration. And network exposure function NEF, it exposes the capabilities of the network and also securely provision from the external services from the external network. An application function AF, they fulfill the role of the application server, that is, they interact with the core network and provide the services. So this slide details the functions of each network elements or the network functions in 5G. So to understand the true potential or to explore the true potential of 5G supporting higher data rate, low latency services or better coverage, the computational capabilities have been moved close to the users or at the network edge, utilizing the mobile edge computing framework or the MEC framework. And this MEC framework have brought new concept in the data center deployment known as the micro edge data centers. So these micro edge data centers are minor and compact version of data centers which consist of this computing, storage and networking resources. They include the power, cooling, connectivity and security features as in a centralized data center, but on a smaller scale. And the advantage or the benefits of such micro edge data center is that they can be quickly deployed, easily deployable by the local community network like the end user communities or the government councils or the non-government organization. And the data centers can be connected to a local smart grid with battery backup, or solar panels can be used for utmost energy efficiency, realizing sustainable and affordable infrastructure technology. So in a local community network, this radio access network and the micro edge data center, they together for the edge-based local content delivery framework in this LCN. So exploring the architectural features of the 5G network and also the novel data center deployment concept, another key enabler for the 5G industrial vertical is the OpenRAN or the Open Radio Access Network. So 5G is meant to support different industrial verticals like automobile for supporting autonomous car, then public safety or mission critical applications, that is disaster mitigations, then utility companies like oil, gas or water. So all these industrial verticals, they will have variety of radio links to the network. They will be user to the network, there will be humans to the network, robots to the network, drones to the network, vehicles or tiny IoT sensors to the network. So to support this variety of radio links, an advanced RAN infrastructure is important in 5G. If you look into the conventional architecture, the conventional radio access network architecture, they consist of the radio units co-located with the baseband processing unit at the cell site. And they are made up of proprietary hardware or software having closed solutions that is lacking flexibility to expand, or they cannot be scalable, and they also hamper the speed to the development or deployment. For example, service provider like Jio, if they want to deploy a RAN infrastructure, they are confined to one particular vendor like Cisco or Ericsson, and they purchase the equipment from those vendor and they need to upgrade the network. They are completely dependent on that particular vendor. But in 5G, they demand a scalable and flexible RAN infrastructure, utilizing the principles of SDN and network function virtualization that we discussed earlier. So OpenRAN, they builds a modular base station software stack which operate on a general purpose hardware. So any vendor software can be run on that hardware. And this RU or the BBUs, baseband processing units, can be assembled from any vendor and plugged together to form the network. So this RAN built by any vendor will be interoperable with any device, core network or any transmission network attached to it. So this diagram shows the OpenRAN reference architecture. The GNOD or the 5G base station will be disaggregated into functional modules, that is RU, radio unit, DU, distributed unit, and CU, centralized unit with standard interfaces in OpenRAN. The RU will be connecting to the DU via the open front hall. The DU will be connecting to the CU via the mid hall interface known as the F1 interface. So this OpenRAN architecture is actually the next generation RAN infrastructure that utilizes the principles of openness, that is open interfaces that enables multiple vendors and operators to customize the services as per the user demand, and introducing intelligence, that is enabling dynamic resource allocation by building virtualized RAN and enhancing the resource allocation efficiency. There are two important layers in this OpenRAN reference architecture, that is the RAN intelligence controller near real-time layer, which is responsible for the latency sensitive or time sensitive real-time functions such as the mobility management, handover management, admission control. And then the RAN intelligence controller non-real-time, which is responsible for the policy management and analytics. The layer integration via A1 interface benefit this RIC near real-time to get intelligently trained models and also real-time control function distributed from the rig non-real-time. And this multi-radio access technology, centralized unit protocol stack, they will be enabling protocol processing and also resource allocation, virtual allocation of the resources. So the benefits of OpenRAN framework can be summarized like it will enhance the operational efficiency, provide effective resource management, effective data optimization, and also automating the services, enhancing the quality and service assurance. All this is enabled by the near real-time rig intelligent controller, which support functions with latency 10 millisecond to 1 second, and non-real-time rig at the system level support functions with functions greater than 1 second latency. And the main objective of this RAN intelligence controller in OpenRAN framework is to support the RAN or the G-Node functionalities, that is the admission control or the interference management, mobility management as X apps or different applications. All these functionalities, as explained earlier, will be delivered as apps. That is, a sequence of X apps will be running at the edge of the rig platform, enabling resource or enhancing the resource allocation efficiency. So this X apps, it's not necessary that should be developed by a telecom service provider. Stakeholders or third parties can open up marketplace to develop the secure X apps. And this near real-time rig enables microservices-based applications, that is the X app. So we can say that this rig-based OpenRAN is a multi-vendor open source platform where a sequence of X apps will be running to enhance the resource allocation efficiency or the radio resource management. So exploring the technical features or the advancements in 5G architecture and knowing more about the OpenRAN, the next is to understand that how emergency services or the URLC, ultra reliable low latency communication services, can be delivered utilizing these advancements in the 5G architecture. So URLC is a key service in 5G or key use case in 5G, which has stringent requirements in terms of latency, supporting a latency of less than 1 millisecond and ultra high reliability of less than 10⁻⁵ outage. So different services comes under this URLC use case, like remote robotic surgery, AR assisted robotic surgery, then industrial automation, mission critical applications, so public safety application, disaster mitigation. All of these applications have their own stringent requirements in terms of latency and reliability. And in the case of this URLC services, the more critical information that is to be shared is the location information. There should be some interaction between the network elements like small cells or macro cells and various devices in an emergency scenario to share information such as location of the sources to maintain reliable services. More recently, drones have been used to fly in the disaster area to carry out the emergency service. So in such dense mission critical environment in 5G, it is necessary to continuously monitor the location of such drones and track its presence or check any faulty drones so as to maintain a reliable service in that emergency scenario. Although GPS or the global positioning system, they provide location services or they locate the devices everywhere on the earth, but GPS cannot be considered as an accurate location estimation technology in a dense scenario of a mission critical environment, because GPS fails inside the building scenarios and also in the densely packed environment. So 5G URLC services, they prefer a UE assisted location tracking utilizing the network intelligence or the location information that can be collected from the service provider point of view. Because in 5G, the service provider split the network into beam-based cells, covering the set of users or the sources. Beam forming requires grouping of the sources. The significant challenge is that in a dynamic, dense environment like a mission-critical environment, to precisely and separately locate those sources, whether it's a drone or sensors or whatever it is, to precisely and separately locate them is a significant challenge within that beam-based cell. So the estimation is expected to be of higher resolution, and UE-assisted location tracking is considered to be of important than the GPS in such GPS-denied environment. And towards the end of this session, two of our MTech students will be showing a demo on how the direction of arrival or the DOE estimation principles can be utilized in such a dynamic environment for locating the sources. And more details on the location of locating the sources with the DOE estimation principles can be referred in this paper, which has been published by us recently. So the technical requirement of URLLC is low latency and high reliability. These are the technical features. So there are some enhancements in the 5G physical layer that can support this ultra low latency and ultra high reliability in URLLC use case. In order to support low latency feature, the first thing is the hybrid ARQ. So hybrid ARQ is a combination of forward error correction and also error control. And this hybrid ARQ can be moved down to the low physical layer in order to enable faster retransmission, thus supporting low latency services. Then another thing is the grant-free access, that is radio resources can be assigned to the users without any prior handshaking process, thus supporting low latency in the communication. And as I explained before, this 5G NR is a scalable OFDM air interface. The scalable interface means it can support scalable numerologies. Numerology is a parameter, like numerology, it actually defines the waveform configuration of the waveform parameter, like the subcarrier spacing, the symbol time, etc. So multiple numerologies can be supported in 5G based on the service deployment or the requirement. And another thing is that this URLLC services can be efficiently scheduled by using a scheduling unit smaller than a slot. So in the case of a slot, it consists of 14 OFDM symbols in 5G. So one slot. In the case of 5G, mini slot concept is available. That is, scheduling the URLLC services smaller than a slot known as the mini slot, which can have 2, 4, or 7 OFDM symbols for short transmissions. And these can be aggregated together to form the longer transmission also. So in this way, the low latency features are supported in 5G. The high reliability features can be supported with the multi-antenna transmission, that is multiple input, multiple output, the MIMO, where multi-antenna transmissions means multiple propagation paths or different propagation paths will be chosen. And that is the same data can be sent via different propagation path or spatial path, preventing the fading and also increasing the spatial diversity is one technique to achieve high reliability. And scheduler can preempt other services and prioritize and transmit the URLLC data. And in 5G NR, it also supports different modulation schemes for different UE categories. That is like QPSK, 16 QAM, 64 QAM, 256 QAM, like QPSK for low data or the control channels, and 256 QAM for high data or the data channel. And there is also like a different channel coding schemes in the 5G NR, like low density parity codes for data channel and polar codes for the control channel. This LDPC or the low density parity codes, they will correct this channel errors, making it more reliable. So these are the technical features and the physical layer enhancements that help to achieve the ultra low latency and ultra high reliability in URLLC. So now we understood what are the requirements for a URLLC service, and OpenRAN advancements have been discussed. Next is how this OpenRAN framework can be utilized to support the 5G URLLC services. So we require an efficient, flexible, and scalable OpenRAN framework so that dynamic resource configuration and allocation of the network functions can be done in a dense mission critical environment. And efficient transport architecture is also required in order to meet the target latency of various URLLC applications. So one of the key enablers in OpenRAN that can support this URLLC service is the protocol split option. The group of software or protocols will be running concurrently on every network devices to establish the effective communication. And in the case of OpenRAN also, this radio units, distributed unit, or the centralized unit, they need to host some protocol stack to establish the communication. And in the case of a dynamic environment like a URLLC or emergency scenario, we cannot expect a fixed, or it is not feasible to have a fixed implementation of protocol stacks on RU, DU, and CU. This protocol split option or the hosting of the protocol stack in the functional module RU, DU, CU is dependent on two key factors. That is based on the network topology, whether it's a rural area, urban area, or suburban area. That is based on the network transport availability there. and also the service requirements that is to be delivered. What are the requirements of the particular service to be delivered? So 8 possible protocol split options are there in 5G. Option 1 is the RRC PDCP protocol split. Option 2 is the PDCP RLC split. Option 3 is the intra-RLC split. That is within the RLC, high RLC, low RLC split. Option 4 is the RLC MAC split. Option 5 is the high MAC or low MAC, intra-MAC split. Option 6 is the MAC Phi split. Option 7 is the intra Phi split or the high Phi, low Phi split. And option 8 is the RF and the Phi split. And there are subvariant of these options also. For example, in order to support the URLs or emergency services, we need quick deployment scenario. So if there's a network topology with like good fiber connection, architecture with good fiber connection, we can go for an option like RU can host the low Phi, distributed unit DU can host the high Phi, MAC and the RLC, and centralized unit CU can host the RRC and PDCP. And that subvariant option for that option 7 is known as the protocol split option 7.2, which helps the quick deployment scenarios in URLC use cases. And mapping the RAN to the transport network, as we discussed now, is also very much important. That is where to locate RU, DU, and CU in order to provide the services. What are the possible distance that can be chosen so that the target latency can be met or dynamic resource allocation is to be done is very much important for this URLC services. So here RU and DU is expected to have a possible distance of 0 to 10 kilometer, supporting a latency, low latency of 50 to 200 microsecond. The split between RU to DU is known as the lowest layer split, and DU to CU connected via the mid-hole interface expected to have a 20 to 40 kilometer distance, supporting 1 to 2 millisecond latency, and backhaul where the CU connects to the 5G core network can be 40 to 200 kilometers away, supporting less than 10 millisecond latency. And the 5G, as I told, the user layer will be consisting of different types of devices. So they need to support variable bit rate in the front hole. So the front hole interface is the EVO Enhanced Common Public Radio Interface or ECP that allows the use of the packet-based front hole to support this variable bit rate, enabling the dynamic resource allocation. So far we have discussed about the architectural advancements in 5G and the key enablers in the 5G like the OpenRAN and how we can act as or how we can play a significant role in enabling the emergency services. So the next key enabler that can realize the sustainable infrastructure is the blockchain. This part will be discussed in detail by my colleague, Mr. Mojdaba. So I invite Mojdaba sir to continue the session.
Thank you, Sir Lakshmi. Hello, everyone. This is Mojdaba Nayati. I'm an international PhD scholar with the Ambita School of Sustainable Development under the guidance of Dr. Punakanti. So let me share my screen with you. I will be explaining the blockchain aspect of this webinar. Let's see what's the role of blockchain to realize the sustainable infrastructure. But before that, let me just cover a little bit about the cryptocurrencies. You all may have heard about it, if not invested on them. There are more than 4,000 cryptocurrencies out there. You have heard about the Bitcoin and its news, the price of it, it goes up, it goes down, and everyone at least heard about it. The Ethereum cryptocurrency and the others. But the general perception about these cryptocurrencies is that the blockchain is Bitcoin. These two terms are in the most cases are seen as equivalent phrases, but it's not actually. The blockchain is the backbone technology of the Bitcoin. Not only the Bitcoin, most of the other cryptocurrencies too, and I can say that all of them are using distributed ledgers as the manner of building up their networks. So what is the blockchain? Blockchain is a linear data structure which is providing us the ability of using the smart contracts. And it will let us to use the distributed ledgers instead of having the central systems like the server and client models. So a blockchain comprises of blocks, different blocks that holds data, information, whatever data or information which is needed in the system. It will connect those blocks of data which are getting created during the time in the system. They are getting connected cryptographically to each other, so it will make it more secure in the different layers actually. And the blocks, every block will be visible and accessible by all the ledger holders, which are nodes that make the concept of decentralization. So there is another aspect to this blockchain technology which is very important, that is once the data has been packed in the block, it wouldn't be possible to getting it changed without noticing the other participants. So that's a very important note over there. So the other aspect of this blockchain networks are having the connectivity of between the nodes. It's a peer-to-peer connection. What does it mean? The peer-to-peer connection is the way of connecting the systems that no priority is between them, like the client and server systems. In the client and server system, the server is all the time is having the upper priority in compare with the clients. But in the distributed ledgers, all the peers are having the same priority in saving the data and talking to each other about the changes or having the voting in the system. So most of the old central systems have been centralized. For example, the web hosting. If you try to open a video in a YouTube website, you should be entering the address of the YouTube on your Explorer, and then this request will be sent to the web hosting server. Your request will be processed, the data will be fetched and will be sent back to you, right? So here is the central server, central database for fetching the data and keeping those data. Another example I may take is the banking system. When you're going to a bank and request for a specific service, they will first, for most of the services actually, they will first check your balance against their central database. And if it pass, then you will be getting your service, right? In the case of universities, all of the data about the students will be kept in a central database, and then for any purpose of doing any process regarding to the students, it will be done to the central part. There is a lot of benefits to the systems, but there will be some critical problems with them. The first problem is that they have the problem of single point of failure. If someone hit the central server, no service, right? The other problem is that the cyber attacker may try to attack to the server. How? They will possess a lot of systems, different tiny systems, and they will manage to simultaneously send the request to the specific server in a way that the server under the attack wouldn't be able to answer to all those requests. So the server again will be down. Only these two aspects that I mentioned are getting a lot of budget from the organizations to be removed or prevented. It is predicted that by 2022, there will be like $133 billion spent on the security of the system. And the other problem with this kind of central systems is the bureaucratic leadership. If the management at the top of the pyramid of controlling an organization come up with an error, some decision, the whole system will be affected, right? So why the decentralization system is better? The first point is, as there is no central part, as there are different nodes holding the ledger, the main database, more than one, a lot of them, there will be no problem of single point of failure, because there is no single point to be attacked. Actually, the cyber crimes wouldn't be happening on them, because again, there is no central server, so denial of service attack wouldn't be possible. Actually, it's not worthy to try, because the attacker should decide how many of them can be down by their attack. So it wouldn't be applicable anymore. And the decision with the decentralized systems are being done after a voting system, actually kind of a voting system. There is no more bureaucratic decision making in these systems. So with this being said, the decentralization is much better than a centralized system. It's more secure. But how do we achieve that? To move towards the decentralization, we should be having a way, a reliable way, a secure way to get this node, different nodes that make the decentralized systems, to make them connected to each other, to make them able to communicate with each other. If any node is going to make any change, it should be telling the others that I have changed this block, or I have created this block, right? So the blockchain is that solution for going towards the decentralization. What is the significance of the blockchain in 5G network? To achieve the slicing technology, as my colleague explained earlier, the private and public entities should be able to share the infrastructure, their processing power, their networking infrastructures, right? So the blockchain will help us in that purpose. For this purpose, the service-based data, the business-related data, along with the user data, will be kept in those blocks, the blocks that I earlier mentioned, that will be connected cryptographically to each other, that will be immutable. So it will let us to use the smart contracts, the contracts that will let us to do our agreements between the entities automatically, without being worried about the risk of the businesses. So this way, there will be a chance to connect the unconnected people in the rural areas. So advantages of the blockchain system to be explained is the blockchain actually can create a network, a framework, a system in a way that the network owners, either the private or the public network owners, to be able to share their infrastructures and the systems in a sustainable way, in an automatic way, in a secure way, and a reliable way. How is that? The sustainability comes with the lower cost in budget, lower cost in timing, in efficiency in the processes. It will come with the system will come with the smart contracts. It will bring up the automaticity. It will be secured within the layers of cryptography in the blocks of data. And as the data wouldn't be possible to get altered after packing into the blocks, it will elevate the reliability of the system also. So as I mentioned earlier, the system is, all blockchain systems are distributed, so there will be no single point of failure there. It will be more reliable as the data is immutable inside the blocks. It will be more secure thanks to layers of encryption in the blocks. The data will be transparent to all the nodes, and it will help the process of auditing in the organizations, in the business agreements. And it will bring up a system, a trustless system. A trustless system doesn't mean that there is no trust in between. Actually, it means that there is no need for a trust. It will do its processes in a way that you won't be needing any trust to trust your other side of the agreement in the business processes. So every node in the blockchain system, in a decentralized system, will be having their private keys, and they will be using their digital signatures to create the blocks. So it will improve the trustworthiness of the system. Coming to the designing factors of the sustainable blockchain, you should be having the sustainability in your mind when you're going to design the system, right? There are several factors in the designing part of a blockchain system, but most important of them are as follows. The first factor is the decision about having your system in a private blockchain, or you're going to have it in a public blockchain. The public blockchain, like a Bitcoin, any one of you, by having a specific computer rig, and of course following the rules of your region of living, you can participate in the Bitcoin's service, right? So it will create a public network. There will be no need for any permission or authentication. But in a private system like a Hyperledger, the nodes should be authenticate and permission before joining to the system. The nodes in a public system are anonymous, and in the private blockchains are identified. Therefore, there are different approaches to prevent the malicious activities in the systems. Let me take an example. If the nodes are anonymous in the public blockchains, what if someone does some malicious activities? How the system will know who has done what? The answer is system wouldn't be knowing it. That's the reason that Bitcoin releasing its coins during rewarding the well-behaving nodes. So there is no punitive system. But in the Hyperledger or in the private systems, there will be a way to identify that malicious node and punish it. So the other factor is the consensus algorithm. As the system is distributed, the nodes are all over the world potentially. There should be a way for the nodes to come up with the latest status of the system. They should agree on a single point, right? To a single status, the latest status of the system. So there are several regular algorithms to be mentioned here. There is this proof of work, which is the famous Bitcoin is using. Actually, it's pretty energy consuming system. The algorithm, there is proof of stake. Another consensus algorithm is POS, or proof of stake, which is going to be used by Ethereum version 2. In that consensus algorithm, every node should be staking some specific amount of money in the system before participating to the system. And there is another one which is pretty well known, the proof of authority, which is the best for the private networks. in those systems, the nodes before getting started the participation into the system, they should be permission. They should be getting the permission and authenticated by the by the system. So also there is this way of designing a specific consensus for the purpose of need for any specific need. There you will be able to have your specific consensus algorithm. So with this introduction being said, what we have done for the 5G purpose, first of all, the proposed blockchain is a private permission blockchain. As the naming is suggesting, it's private. That means the nodes before starting the participation should be identified, right? It should be getting permission before starting creating the blocks. So in other advantages in the private blockchains, everything will be faster. Unlike the Bitcoin system, which you need to stay for 10 minutes to get your transaction into any block, and another 5 blocks, like 60 minutes to get it confirmed totally. That's not the case here. We will be having a private permission blockchain. It will be much, much faster in block creation and confirmation. It will be preventing the malicious activities because all the nodes are identified. Scalability, which is a very common issue in different blockchain-based projects, is not an issue here because it's a private blockchain and it will be much more scalable. In case of block size, actually, I should say this, that the blocks can be having a specific amount of capacity for holding the data. Getting it larger in a bigger size will create different problems. Having it small will create different problems, but having imbalance is a way of having the victory in the designing phase. But in the private blockchain, it's much, much more flexible. There is no need for voting for that. Each public and private entities will be a node. Every network holding entities, when it's either it's a public network or a private network, they will create a node and it will participate in the system by holding the ledger, an identical copy of the ledger. So the most important section of this proposal is that we have come up with a novel consensus algorithm. We call it proof of connection. Proof of connection is trying to implement the proof of authority with the use of proof of stake. It is specifically designed for the 5G purposes. It will be very high performance. It will be using much, much lower energy than the proof of work, like in the Bitcoin. So there will be no mining in that sense. It will be very energy efficient. Nodes will have to be authenticated first and then stake a specific amount of digital asset before participating. As you see, there is this authentication for proof of authority and the staking money for proof of stake. You can see that it's a mixture of these two. And it allows the subscribers, the mobile subscribers, to stay connected when they are not able to reach their home service provider network. So how it let the infrastructures to be shared. Proof of connection lets the private and public networks owners share their infrastructures, their processing powers and their networking infrastructures in a fully automated manner, because we are going to use the smart contracts. The blocks will be visible to all the nodes, so it will be auditable. The reliability in the business agreements will be elevated here. So when the private and public networks are going to agree, is at the time of initiating the service for the subscriber. So they will agree on a specific term based on the subscriber's demand, and then the smart contract will be initiated by blocking the asset from the home network of the subscriber and keeping it until the terms of the agreement are met by the visited network. So the data will be holding the agreement data, like the quality of the service data there. So this way, the smart contract will know when the agreements point are met. There will be a specific local digital currency for this system, and it will be kept in a specific digital wallet. So these wallets and cryptocurrency will be used for initiating the smart contracts, which are getting executed by the different nodes, and for the punitive purposes, of course. Here it comes the sustainability part of it. As Dr. Panakanti mentioned earlier, there are different aspects to achieve the sustainability. And here, the blockchain system, with reducing the financial aspects and the timing cost, of course, will be helping us to achieve the sustainable system. There will be no need for a third party in the agreements. The cost of auditing will be much, much lower than the previous systems, the regular systems, the traditional systems, may I say. And the agreement preparing cost will be much, much lower, because the smart contract is going to do it. And the transaction cost will be much, much lower. When you are going to the bank to or send some specific amount of money to other part of the world, you should be paying some transaction costs, right? So in this system, that thanks to a private blockchain, there will be no or almost zero, near to the zero transaction cost. The business risk will be much, much lower, because the system is trustless. The business entities wouldn't be needing to trust the other part, because all the parts are having a lot to lose if they misbehave, right? You remember the punitive system? We stake a specific amount of money from their wallet. So if they do mistake or having a misbehavioring, so they will be losing a specific amount of money. Therefore, the business risk will be lower. IT infrastructure costs will be much, much lower, because the system is going to work for itself. The timing cost will be reduced, because everything is automatic, everything is processed by the different nodes in a matter of seconds or less than a second in different cases. So I didn't go very deep to the blockchain side, respecting to the variety of the audiences, but I will be more than happy to answer your questions if you have any. So my friend will pick up the stage to continue. Thank you so much.
Thank you, sir.
Thank you, Mustafa. So Srilakshmi will walk through the final 2 slides of the reference design that will bring the private networks and the 5G toolbox of things, and then the edge component. to show. Srilakshmi, please take
Yes, sir. Sure. So far, we have been discussing on the key enablers that can realize the sustainable infrastructure for LCN. So now we shall discuss on the deployment scenarios or options possible in the local community network and what are the significance of these roaming models in LCN. So as we discussed earlier, this local community network can be deployed independently by the end user community, that is independent of the public 5G network. So option 1 is to deploy a physically isolated private 5G network independent of the public 5G network as shown in the left hand side of this figure. And option 2 is to build a private 5G network by sharing the public 5G network resources as shown in the right hand side of this figure. So in this figure, here, the local community network operator or the owner is the enterprise. The enterprise is deploying the network completely independent from the operator's 5G network, and the enterprises will have the full 5G network set. That is the 5G G node B, user plane function, the mobile edge computing, 5G core, control plane function, everything deployed on the premise of the enterprise or within the private network deployment. And here, they will use local 5G frequencies, like freeing from the mobile operators licensed frequency. And this enterprises, the private network, the data generated by these private network devices, the subscription information, the operation information, everything will be stored and they'll be processed within this enterprise itself. No data will be leaked outside from this private network deployment. That is, in case the mobile operator's 5G network failure occurs, the enterprise private network will be working well in this option scenario, in this deployment scenario. In the second option, where the private and the public network resources are shared, that is, there happens a logical sharing of the RAN and the core network resources that is enabling end-to-end network slicing. So here, this is one scenario where the 5G G node B will be deployed on the site of the private network, whereas the UPF, MEC and the 5G core control plane will be on the operator's edge cloud. And here, the 5G G node B and the user plane function will be on the premise of the enterprise, and the MEC and the 5G core control plane will be on the operator's edge cloud. That is, the private network devices are interworked with and managed by the operator network. So the private network data generated by the private network devices or the private slice, they will be delivered on the private UPF, and the data network traffic generated by the public slice or the public network devices, they will be delivered on the operator's edge cloud. That is, there is an edge-to-edge interaction happening here in this deployment scenario. Then the significance of roaming in this LCN deployment. So roaming, it's a process where the mobile subscriber, like when traveling outside the geographical coverage area of their home network, that is the current network to which the subscriber is registered with, he or she can enjoy the services or make or receive the calls by means of a visited network. So this architecture actually shows the 5G SBA roaming architecture. In 3GPP, right from the 2G, there are well-established roaming models to support roaming services for the mobile subscriber. So here, for example, this is the home network, home public mobile network. The subscriber's home network is in India, let it be Geo, and the subscriber roams onto the visited network, let it be the other country like Abu Dhabi. Etisalat is the mobile operator provider there. So the subscriber can receive the services if the roaming agreements happens between the home network and the visited network. So the SBA here, this is the service-based architecture that we have discussed earlier. So the SBA in the home network connects to the SBA in the visited network through secure proxy known as the secure SCPP via the N32 interface, and IPX. Packet exchange is there, which can route the packet from one network to another. And in this roaming scenario, the end-to-end quality of service is a combination of the visited network, which will be enabling the network quality of service, and the home network, which will be handling the subscription profile and billing of the services. So based on this, there are two types of roaming models, that is local breakout and home routing. In local breakout, the data traffic is routed directly from the visited network to the data network, and the basic roaming and basic roaming policy and charges will be applied by the visited network as per the roaming agreements between the VPMN and the HPMN, while the authentication and the subscription, handling of subscription data will be managed by the home network provider. And in the home routing model, all the data traffic from the visited network is routed to the home network to the data network, and the billing of the services will also be done in the home network. So why we are explaining the significance of roaming model here? So the more details about the roaming implementation can be found in this source. So why we are explaining this roaming, significance of roaming in this LCN deployment scenario, because we have explained in this deployment option, when there is a sharing between the public and the private network resources, there is edge-to-edge interactions happen. And this edge deployments are increasingly becoming popular nowadays, that is moving the core network functionalities close to the edge. That is known as the edge federation. So in the case of a local community network deployment, there are two types of operator. The edge transactions or interactions are happening between the LCN operator and the public mobile network operator. So this roaming principles that is applied now here, or that we have understood, can be applied to evolve towards the edge federation, or inter-edge roaming principles become important in exchanging the public and private network slices to support sustainable slicing. That is, the aim is to securely and transit, or the smooth transition of the public and the private network slice to support sustainable slice in LCN deployment. This actually is under discussion, and we can anticipate that this core network SDA roaming will be evolving towards this edge federation in order to support the inter-edge roaming principles in LCN deployment. So connecting all the key enablers that we have understood from the session, and also understanding the principles behind the deployment scenarios of this local community network, the next step is to go into detail about the design framework that can realize sustainable infrastructure in local community network. So this design framework has been designed to support the local community, especially focusing the fishermen community. Or the coastal people, as Setu sir has addressed initially about the OceanNet platform. So Amrita University have an ongoing initiative like OceanNet platform, that's the offshore communication platform to support connectivity services to the fishermen who goes far away from the shore from the harbor for the fishing purpose. So that is the starting point. But in order to make it a sustainable infrastructure, some upgradation is required. That upgradation starts from the node Bs, upgrading the node B, and also bringing the computational capabilities close to the edge, or at the network edge, or at the local community. And for that, we can say that, as we have discussed, one of the key enabler, the micro edge data center. So upgrading the node Bs and bringing the computational capabilities close to the edge or at the local communities will be realizing this virtual ports, that is programmable open deployments that can run network function instances dynamically to serve the users. And this virtual ports or the virtual data centers will be deployed locally on the land, or in the case of an OceanNet scenario, it can be deployed on the boat or containers to provide the services. And this group of virtual ports can be deployed at different locations of the village or the rural areas, or in the boats or containers as in the OceanNet scenario. And this group of vPorts can be connected to an aggregation data center which has sufficient computing capabilities as a centralized unit in an OpenRAN framework that we have discussed earlier. And that aggregation data center will be connected to the LCN network operation or the local community network operation center. In the case of an OceanNet platform, it becomes the Amrita Operations Center. And this Amrita Operations Center should be then upgraded to accommodate the synchronization module, blockchain module, and private network deployment module to provide different sustainable functionalities. And the ultimate aim is the end-to-end smooth transition of the public and the private network slices. So to manage the slice, the network management layer at the local community network operator or the Amrita Operations Center should have some open source platforms that can accommodate the public network domain controllers like the RAN orchestration, software-defined wide area network orchestration, or network service orchestrator that supervises the service or the slice initiation to maintain and assure the service quality. So the local community network and the public network operators work together to ensure the service continuity in such a LCN framework. So here the sustainable slice manager will be monitoring the smooth transition of the public and the private network slices between these networks, and the vPod manager, they will be monitoring these virtualized ports that will be deployed locally on the LAN or on the board. And configuration of that, and also gathering the performance statistics of the virtualized data centers. So this LCN proposed framework, it is actually realized with some 5G interoperable solution. So this solution, when combined with the development of regional language apps, they can facilitate improved efficiency of small businesses and also localized supply chain management. That is to realize a localized circular economy and utilize this infrastructure as a local marketplace to sell the goods and also to share the news in the event of the disaster. So we have published a paperwork related to this reference design framework, and for your reference, you can refer this recently published paperwork. And to summarize about that, like we have been addressing mainly on the digital split that exists between the rural and the urban communities, because in rural remote areas, they have not completely experienced or benefited any value of the wireless internet access. But to sustain the progress of the world, it is necessary to have digitalization in every aspect. So solution to the digital divide, the following principles were understood, that is understanding the societal needs of the rural communities and the sustainable development goal. The key potential was to explore the capabilities of the 5G latest cellular technology, and based on that, and to realize the reference design framework that adopts the best breed of the 5G technology enablers, that is the OpenRAN, network slicing principles, private network deployments, and blockchain to realize the sustainable infrastructure. And it is also that this resilience offered by this 5G network can bring this currently disconnected rural communities into the digital sphere. That is, digitalization is considered as the key engine for the sustainable development. So thank you so much. If you have any questions.
Thank you, Srilakshmi. We will take the questions towards the end. We would like to move to now invite our current students. It's a pleasure to invite first Tom, Toby, and Makaran Prabhu. Please, can you quickly show your experience and the platform that you are beginning to develop now?
Thank you, sir. We are grateful for providing us an opportunity to be a part of this webinar. Hello, everyone. I am Tom. I'm a first-year MTech student at Amrita Center for Wireless Networks and Applications.
Hello, everyone. And my name is Makaran. I'm a first-year MTech student at Amrita Center of Wireless Networks and Applications. So we have developed a GUI for DOA estimation, and we intend to walk you through it with the help of a thought experiment.
Okay, that's right. Suppose I'm a malicious guy and I'm trying to attach some ballistics onto a drone. And my plan is to attack a critical infrastructure. Say, let's suppose an airport.
Then I'll be the chief of security at the airport. And the security system deployed at the airport can detect the presence of alien drones in the vicinity. It consists of an array antenna, which will be used to estimate the direction of arrival of the signals coming from the drones.
Okay, then Makarand, I know your office location. Okay, you can think like that. And I'm going to send a drone at 20 degrees to your office. Will you be able to track my entry direction?
Sure, Tom.
Okay, let's see.
We have the facility for that. So we have an array antenna setup, which contains 20 antenna elements. So we'll set it to 20. Let me just this. There's no option to minimize the Zoom panel. Okay, let me just give me a minute. I'll just share the screen once again. Yes. So to continue with our thought experiment now, we have this facility of, so let's say we have an array antenna which contains 20 antenna elements, and it can pick up at least 100 snapshots of the signal that your drone emits. So let's set the number of snapshots to 100. So one drone meaning one user. And the incident angle, which is the angle between the normal to the array antenna and the direction vector of the signal, is known to be 20 degrees. So let us set that.
Yes.
And let's take the phase difference between the array elements of the signal to be 45 degrees. And let's say the SNR value of the signal was found to be 10 decibels. So by taking these parameter values, let's see whether it could track the DOA of the drone.
Okay, Magan, let's check it.
As you can see from this graph, the system worked excellently. It estimated the direction of arrival of the drone with zero error in estimation, and also with a high resolution.
Magan, this is very impressive, but I also have kept another drone with me ready, and I'm going to send this time 2 drones, say from an angle of 20 and 40 degree to your office. What will happen here?
Yes, Tom. I'm sure we can track both the drones here as well. So we have 2 incoming drones, like you said. One is at angle of 20 and the other at an angle of 40 degrees. So 2 drones meaning 2 users. And let's set the incident angle of the second drone to be, signal coming from the second drone to be 40 degrees. And let's take the phase difference between the array elements for the second signal to be 90 degrees. And the SNR was found to be 10 decibels here as well. Let's see how well the system performs.
Okay.
So we see that the signal sources could be estimated with minimal errors in estimation for each of your drones.
Okay, Magarand, I'm really impressed, but I'm also a resourceful guy. Say, I'm going to send 3 drones this time at an angle of 20 degree, 40 degree, and 60 degree towards your office. And what will happen? Like, will you be able to track my direction this time? There are more candidates to be tracked.
Well, our track record, as you can see, has been impressive so far. So why not improve it further?
Okay.
So 3 drones, meaning 3 users. And the incident angle for the third drone is set to be 60 degrees. And the SNR value was found to be 10 here as well. And the 3 drones have different arrival times. So let's take the phase difference for the third signal to be 30 degrees.
Oh, this is good, Magarand.
Yeah, there you go, Tom. So we were able to track your drones in this case too, although with a bit poorer resolution. Maybe you could come up with a better plan next time.
Yes, Maran, but I'm also an optimistic guy. Like, I understand that every system must have some vulnerability. So I will try to send them differently this time. Say, I'll be trying to send 3 drones at 40 degree, 45 degree, and 50 degrees. They're very close now. So what will happen this time? Even if you miss a single drone, Makaranda, you understand, right? Even if you miss a single drone,
Yes, yes.
I'm a successful guy.
So this sounds more challenging. So
Yeah.
why not give it a try for closely spaced sources as well?
Sure.
So at incident angles of 40, 45, and 50. Let's see how well the system performs. Looks like our system could manage to track just 2 of your 3 drones. Although, and the resolution could have been better. You win this round, Tom. But know that we can be resourceful too. Let's say we have upgraded our array antenna, and now it packs 80 antenna elements.
Okay.
And it can capture 200 snapshots. You can try sending your drones this time.
Okay. Consider it done.
So now you'll find that the upgraded system showed a higher resolution than in the previous case.
That's good, Magarant. But suppose I come up with a new situation. If I can maneuver 3 drones and make sure that you receive coherent signals of my drone simultaneously, and say at a phase of 45 degrees, will you be able to track my drones this time? So far, we have looked at a different case.
Yes. Yeah, we can certainly try to evaluate this scenario as well.
Okay.
So for coherent signals with phase difference of 45, looks like we missed one of your drones. And I'm sure we can improve our system and catch all your alien drones next time.
We surely can, Magarant. We surely can.
Is the screen visible?
Yes, yes. Okay, everyone. So we have gone through a thought experiment. Let's connect some more ideas to it and let's get more information from it. So what we have done is like direction of arrival estimation. So for our particular visualization, DO estimation was conducted only for static sources in the study. And the future scope is to extend it to dynamic sources as well. And DO estimation here was done using singular value decomposition. This method was chosen over eigenvector decomposition because it had better efficiency and arithmetic advantages. And the use of DO estimation in a mission critical application is demonstrated in this study.
So to add to these points, DO estimation has a lot of potential in 5G communications to support mission critical applications such as drone and missile tracking. And this localization process, along with the use of APIs, image analysis, and deep learning techniques, and along with the information from identity servers, has tremendous potential to provide ubiquitous coverage, seamless mobility, and highly reliable and secure services in mission critical scenarios, such as the one presented in our case study. And another advantage of DO estimation is that it can be used to provide services in GPS denied locations as well, such as deep inside a building or in underground locations.
Okay, let's understand how mobile communication network is a key player here. Like we know, 5G communication is already beam-based and has better networking and processing capabilities. So DO estimation is naturally complement to this technology. And we already know that the current mobile network operators have nationwide infrastructure, including base stations, subscriber base, and network capabilities to implement hyperlocation-based services using DO estimation. In our visualization, we only tried using a single base station. So we should think how much the mobile network operators could do with a wide network. And another advantage is that no additional hardware equipment is needed, as the network functions can be implemented in software, like network function virtualizations and all. And 5G can use DO estimation for user-specific beamforming to provide reliable services to the users. That is for the viewpoint of 5G. But as the mobile network operators, they can also render critical services such as we have discussed here, like providing security and reliability to enterprise level infrastructure. Thank you.
Thank you.
Many thanks, Tom and Makran, for your presentation. Next, we would like to invite Rahul to quickly share his experiences in WNA and what he learned, the outcomes. Rahul, please take the floor.
Thank you, sir. Thank you very much. I take this opportunity to thank each and every one of you in number of all the faculties, especially the director Manisha ma'am, Sedu sir, Sheshaya sir, and all the faculties who have been supporting all through the course. First, let me share my screen. Is my video visible? I'm sharing my PPT.
Visible now. Yeah, go ahead.
Okay.
Yeah, but slideshow mode, please. Yeah.
Yes, sir. Sure. Hi everyone, I'm Rahul. I'm from Kerala. Basically, I'm a BTech graduate in electronics and communication. And after that, I had a work experience of about 4 years as system in Kerala State Planning Board, IMG, etc. And after working for some years, I felt that there is a requirement to improve my knowledge, particularly in the area of wireless. That's how I came upon the Center for Wireless, which offered MTech courses. So I'm a first year student of the Center for Wireless Networking in WNA. So here I would like to share some experience which I have been along with my other students who have been giving you an excellent presentation, like Tom and Magaran. That is the key element. We have been trained in all these things, which are fundamentals of mobile networks. Firstly, I would like to say, during my first year, I was part of the curriculum where we were trained in MATLAB, other tools like programming in C++. And when it comes to mobile networking, we have given the basics of principles of wireless communication, where we were trained in software such as radio mobile and other elements which helps us to analyze the parameters which are taking place in the real world in a mobile communication scenario. And coming to the second semester, the particular courses which we provided are machine learning, IoT, and mobile communication network, along with other courses. And as part of this webinar, I am going to share some of the key points which were covered in the mobile communication network course. And from this, I would like to give you a higher level understanding of the service evolution of the mobile network. So, as you could see, this is our, I could say, ladder architecture of our service evolution. If you people remember, there were initially the 2G network in the era of 1990 to the year 2000. Particularly, I am saying this with respect to India. From the period of 1990 to 2000, we were having 2G mobiles, where the primary or basic intention is for voice calls, SMS, and little bit of minimal web browsing just to read some things in minimal web browsing. That I would say something like news content or basic element applications such as Facebook or something, but not what we use today, but it was very minimal. And as you could see, the download data rate, which was only up less than 0.5 Mbps. And then came from the year 2000 to the year 2010, the onset of 3G mobile communication, that is called HSPA. The user or the service evolved much more than basic primary voice call or SMS. It began the era of new data technology. From the basic voice only technology, it became a mix of data plus voice technology, that is IP, and coexistence of IP and standard legacy technologies. So we began to use video calls, data, and MMS, because it has got a higher data rate of about 7.2 Mbps in the download. And you all know, from the year 2010 onwards, we have got 4G LTE, and 2010 to 2020, even 4G is the existing technology in most of the part of India now, where we are, maybe many of you have been attending this webinar in 4G, I can say. And it has got much more broader service delivery in addition to the voice, the SMS, and it has got many other things, such as, if you could see, MBB, that is mobile broadband. Mobile broadband means we all have experience in broadband connectivity in all our homes and offices, etc. So with 4G, mobile broadband connectivity, that is data rates which are closely matching to the broadband connectivity, could be established to the users. See, there is a downlink data rate of 150 Mbps and uplink data rate of 50 Mbps. That was that is the data rate of the 4G network. So the user experience of 4G network is almost known to everyone. From 3G, it began the era of mobile marketing, or we could say the apps such as Amazon or other e-marketing apps. It became mainstream. But when it comes to 4G, the services we use, such as mainly it is in the range of video streaming, high definition video streaming, high definition calls, etc. Many of you may be subscribing to Netflix, Amazon, etc. So that is mainly due to the data rate provided by the 4G. And there comes our 5G. It would be, now itself, there are 5G handsets available in the market. So I would say from 2020 onwards, it is the era of 5G. If you see the range of services offered by 5G, it is in addition to the basic voice call, but that is not the peculiarity of 5G. But the other things, that is 5G has become an IP-only network. And by saying that 4G was also beginning of flat network, and now 5G becomes VoNR, or voice over new radio. And then comes the other service, that is USD video calls, which could be possible, because if you would see the data rate of 5G is in the range of greater than 10 Gbps, and with an upload of greater than 1 Gbps. And the three boxes you see there, EMBB, that is enhanced mobile broadband, massive machine type communication, MMTC, and URLLC. And from the previous presentations of Sri Lakshmi ma'am and Mohta Basar, you'd have here heard very well about URLLC, that is ultra reliable low latency vertical of 5G. That is being used especially in the future for URLLC is very low latency, that is 0.5 millisecond user plane latency is being considered as URLLC. When we say 0.5 millisecond latency, if many of you are hearing to this webinar via your Bluetooth headphone, it have a latency of about 50 to 100 milliseconds. So consider 0.5 millisecond is how quick. That is the particular use case scenario of URLLC that is being used in AGVs or autonomous guided vehicles, where little to no human intervention is needed to control or drive the vehicles. And other things are mission critical services. Mission critical services, an overview was given by Sri Lakshmi ma'am, for example, in healthcare scenarios and other scenarios, which are the communication should be happening under very low latency. And then comes MMTC. There, it is the connectivity of smart cities, smart homes, etc. There, the latency could be it could be a trade-off, but it is very much of having MMTC connectivity, because power-sensitive devices could be using MMTC vertical. And there comes EMBB, where companies could make use of the high gigabyte or peak data rates of 20 Gbps. And I would like to say some of the unique features of 5G. This is a comparison between some of the key technologies which we have been using now. One is 5G, other is 4G, the another one is Wi-Fi 6, and the last one is NBI. We plot a comparative study between all these technologies with respect to speed, latency, connections, device energy consumption, and range. You could see, is my pointer visible to everyone? I hope
yes, it is visible. Please go ahead.
Okay, thank you, sir. Yeah, if you could see this graph drawn over here in black lines inside this pentagon, that is representing 5G, and the one in a light blue color and the shape of the boomerang, which is drawn over the center, it is 4G. See, in just a comparison between these two, there is a trade-off for all these technologies. There is a trade-off between speed, range, latency, connections, and device energy consumptions. If we try to attain a peak in any one of these, the other values would have to be compromised. But in the special case of 5G, the 5G attains a very high range. It excels in speed. It is very much improved upon the latency. That is, if you could see the diagram itself, it is very evident. The latency of 4G or any other technology, Wi-Fi 6 or NB-IoT, 5G excels in the latency and reliability vertical, and the number of connections. The number of connections, if you could say, it is very massive. Up to 1 million connections per square kilometer could be delivered by 5G. And when it comes to device energy consumption, 5G is also excellent in the sense that it is very useful for giving connectivity to power-sensitive applications. And at that point of view, NB-IoT excels, because NB-IoT is dedicatedly, NB-IoT, if I could say, it is narrowband IoT. It is dedicatedly for IoT, the connectivity of IoT devices, where we could expect at least 10 years of battery life for the sensors, where we are using NB-IoT technology. So 5G approximately matches to the device energy consumption of NB-IoT 2. And when it comes to range, 5G excels almost everything. And this is a summary I have to give you from my learning experience of this first year MTech in Amrita. My first learning experience I would like to share is we have been given classes in network quality assessment. So it is based on certain mobile apps such as Cell Info Live, where it helped us in giving insight into various RF parameters, including RSSI, the throughput, and latency. We were able to study, especially in the period of this pandemic. The learning is online. People would say how technical people are going to do their labs. But here we were provided with excellent facilities. The greatest technology which we have at our hand is our smartphone. It has got so many sensors which we have not been used yet. So we were introduced to certain apps which could tap on the features of our smartphone, which we didn't use till now. So network quality assessment which could be used based on the smartphone technology apps were introduced to us. And the second learning is the practical sessions on DOA analysis. DOA analysis is what just Tom and Magrant have given you an introduction by excellent software they have developed with the help of our Seshaya, Sri Lakshmi ma'am, etc. And the platform is MATLAB. And the DOA estimation analysis, it helped us to understand the methodologies in DOA estimation, such as SVD, music algorithm, etc. And it provided insights on how location-based beamforming is provided in 5G, especially when it comes to mission-critical services. If you could have seen the last slide of Sri Lakshmi ma'am, the mission-critical services, especially when the services that should be delivered inside some places disaster have occurred, except for example, inside a tunnel where GPS signals could not be received. This type of beamforming techniques could be introduced, and there are many applications in mission critical services. And the last and the third learning which we obtained till now is I would like to share is the case study. There are many case studies given to us, and in particularly in mobile communication network, the case study offered to us provided an opportunity to understand the network, the traffic, and the service evolution towards 5G. And I have no doubt that if something beyond 5G is there, Amrita would be the first one to introduce all those in the curriculum. Thank you.
Thank you very much, Rahul. Then finally, we pass on to Parvati to give your experience.
Yes, sir. Namaskar all. I'm Parvati SS, and I'm a first-year MTech student at the Amrita Center for Wireless Networks and Applications, and I'm a BTech graduate in Electronics and Communication Engineering. First of all, I really wanted to thank all the faculties who gave me this opportunity to share my course experience and also my case study work experience. Hello, am I audible?
Yes, you are. Go ahead, Parvati.
Okay. So during the last year, when I got an opportunity to attend the webinar that was organized by the faculties here in WNA and also the CCSR, some of the key points as a student that attracted me towards WNA was the interdisciplinary course pattern that is provided here, which opens us to different courses that we can pursue further. And also the different projects that are being ongoing that is happening here in Amrita, like the offshore communication, OceanNet and all. And what really made me join in WNA was that the courses are related to the latest trends in the industry. So I will start sharing my presentation. I hope it's visible to all. So as a part of the program in WNA. Okay, sir. Okay. So, yes, sir. So as part of the MTech program here in WNA, during this first year, I got an opportunity to learn some of the courses that are related to latest technologies and trends in the industry. And some such courses are the mobile communication network, software-defined networking, machine learning, Internet of Things, and the wireless sensor network. Share my case study experience in my course, Mobile Communication Network. So as part of this course, we were able to understand about the evolution of the mobile architecture from 4G to 5G, their protocol stacks, and also the changes that happened in the protocol stacks during this evolution. So this helped me to realize how the architectural enhancement from the 4G to 4G cups help the network operators in the flexible deployment of the network elements at the cloud and also at the edge location. So as part of the coursework, my in-depth detailed case study of the network core function evolution from 4G to 5G. I hope this figure is visible to all of you. It is showing the core function evolution from the 4G to 5G architecture. So here it is showing the different network elements of the 4G and the network functions in the 5G. So with the architectural evolution, how the network elements got mapped from the 4G to the 4G cups, and from the 4G cups, how the network elements got mapped to the 5G network function is being shown here. The network elements shown in the yellow box are representing the user plane elements, which carries the actual data traffic in a network, and all the other boxes are showing the control plane elements that carries the signaling traffic. So in the 5G also, the control plane user plane separation is being enabled, which allows the scalability and also in the decoupled technical evolution. And this is allowing the network operators for the flexible deployment of the network elements at both at the centralized and also at the edge locations. So since the 5G, there exist various radio links, not only from mobile phones to network, but from humans to network, sensors to network. And also we know that there are networks from vehicles to network is there. So 5G is really about connecting things everywhere, that too reliably with low latency and then compared to the 4G. So 5G is a single network that is serving different verticals like utility companies, enterprises, etc. So this case study work, with this case study work, I was able to accept how the single network is able to serve different verticals by understanding the concept of the network slicing. So in the network slicing, different network functions are combined to form the logical network to meet the performance requirements of the application functions and also the different services. So as Felix ma'am discussed in the webinar about the service-based architecture, it is allowing the plug-and-play deployment of the new features, and the network interactions is possible via the application programming interfaces. So this understanding has helped me to appreciate why 5G is becoming more softwareized. That is, in order to support the wide and the heterogeneous set of the 5G use cases. And the 5G network function virtualization is slicing the network to support these various 5G use cases. And with software-defined networking coming, both the control plane and the user plane separation is now possible, and it is providing more flexibility and also programmability without any much change in the network architecture. So in the 5G protocol stack, it is making use of the HTTP2 as the application layer protocol for the service-based interfaces with the control plane, making 5G an IT network model. So this figure is showing how the network slicing is supported in the 5G for the different use cases. It is making use of a common access and mobility management function, and they are making use of, this is made use by the different multiple slices, and each of the slices, as we can see, they are making use of different network functions as per the requirement of the 5G use cases. So this MTech program at WNA offered me different courses that are central to the recent advances in the industry. So the learning outcomes or the skills that are acquired from this particular courses are, we were able to perform different lab exercises, and we were able to analyze the performance of the network using the already existing apps like Rahul Chetan mentioned. The different apps like the Cellular Light and OpenSignal were used to study and to understand how the network is performing in our area by considering the RSRP measurements, throughput, and also the latency. And we also had in-depth system design and also architecture. We learned about the architecture of the 4G and 5G and the control plane procedures and different protocol stacks and also the network elements. So this has helped me in accepting the changes from the legacy 4G to the 5G via the cup. So the importance of the 4G and the unique capabilities includes the ultra reliable low latency communication has able to support the mission critical applications was also understood from this. So all these understandings from this course really helped me to appreciate how a programmable network with the 5G service-based architecture supports several different applications and also different verticals. Thank you.
Thank you, Parvati. So I think we have concluded all the presentations and we can take any questions and comments. Yeah. We thank everyone for your time on this call and on this webinar. We covered various aspects and experiences. Yeah. So are there any questions that we are seeing, Ganesh, on the I see some chat questions on certificates and other thing. Every participant, as you said, will get a certificate. Yeah.
Yes,
and some future seminars are informed also. Yeah.
One question is from Subha Prakash Giri. So how to migrate core network function to virtual network functions? What are the important steps and considerations?
Okay. So that is a good question. We have to, that's a little bit like a practical question. Generally speaking, the mobile core networks follow certain specific model when you are trying to go virtualization. You can even download some deployment guidelines, public available from Cisco and some other companies. But generally, you choose some software. First, you need to set up and configure some hardware operating system and set up the server, storage, and networks. These are all, if you look at the XC NFV model, it's almost logical, but it really translates nicely into practical. So then you install your virtualization software layer. So then you verify the installed virtualization software, and then you provision your manager for it. It's called Virtual Infrastructure Manager, so that you can control the NFVI, and also the storage and network. Then you also need to test your interfaces to the hardware and OSS interfaces, and then security. There is a lot of templates in this to be able to do. You can do it based on VMware and other frameworks. So it's a detailed design topic. We will be happy to discuss with you offline, but I think there's some information on the literature also on how these virtualization can be realized, how you can move from physical to virtual, native architecture to virtualized architecture. So you need to choose the hypervisor and various functions within that. Okay, I hope that answers to some degree, but a little bit more reading and things may be needed. Yeah.
Sir, one more question. So what is the future of cognitive radio technology in the field of wireless communication?
Yes, I think this is a very relevant question with the topic that we are talking, is that we would like to use the spectrum. Spectrum is very precious, and spectrum is becoming available now for private networks. And there will be a lot of, if you like, several people using the spectrum. And if you want to understand practically, you need to read on the websites something called CBRS, Citizen Band Radio System. And this is being deployed in America, where the network sharing some of the, what is the free spectrum that I can share? Because everyone is sharing a free spectrum, including the defense people. So those are early versions of the cognitive radio in the industry sense. Similar ideas will become more popular as we go forward in the in the 5G private networks, CBRS, you need to look for priority access license, PAL, they call it. If you look at the PAL deployment, it becomes very clear that is a certain kind of cognitive radio early principles may be used by it. So generally, in the early stage of femtocells or small cells, each of the small cell comes up with a software called sniffer, or femto forum or small cell forum calls it a network listening module. So this network listening module is scanning the its surroundings and trying to find out who is using this network, and then only use the frequency that others are not using. So these principles are going to be coming very clearly into the 5G and beyond also. So yes, cognitive radio is going to be very important. How to sense the spectrum. Nowadays the word sensing becomes very general. Cognitive radio has been there for a long time and it will play an important role. So spectrum sensing is very important. What kind of spectrum that I can use. I hope that gives some ideas on the more practical side, and then when you go to machine learning and all this wireless AI that a lot of 5G experts are talking about, they also involve trying to understand activity on the spectrum so that you can decide how network is getting loaded and how many resource blocks should be given for particular service and predict the service also. So yes, cognitive radio definitely is going to be very important in this research.
Okay, sir. Thank you. So one more question is there. Can you share some thoughts on the application of 5G for compassion-driven research?
5G for compassion-driven research. I think it is generally sustainability is what we address quite a lot. So I would like to understand this question more as to compassion from what sense. So I think the question needs to be a little bit more clarified. Definitely, current systems are not great in terms of sustainability, and also communities that cannot afford our idea. And also, as Srilakshmi explained, there are initiatives with Facebook called Telecom Infrastructure Project, TIP. They are all trying to bring connectivity to the digitally unconnected communities. So there is a little bit of motivation for them, but generally speaking, 5G to save lives, 5G to meet the emergency disaster scenarios, those are all somewhat closer to the compassionate view. But if there is any specific topic we would like to hear, because here in Amrita, we would like to do technologies that matter more. As you said, we are looking into this OceanNet platform that provides connectivity to fishermen who goes for long distances in the sea and do not have any connection. So yes, I think there is it's an important item. Any specific ideas from you have, we can definitely consider, we can look at it.
Okay, sir, that's all from the question and answer session.
Okay. So we can provide the presentations also, Dinesh, right? After this, after for all the registrants together with the certificate. I hope you attendees have seen that the technologies are evolving rapidly, but in Amrita, our approach is to start simple and expand and use the existing techniques in the current COVID situation and try to learn and also step into more open source and local needs, combine them and advance into the research. So I would like to thank my the team colleagues here, starting with Lakshmi joining remotely from the British Telecom Laboratories, and then Sri Lakshmi presenting through the overall toolbox, especially borrowing the 5G technologies and combining them to the OpenRAN and private networks, and then Mostaba taking us through the options that we have and the blockchain capability in the smart contracts, and then followed by students Tom and Tom and Makaram, sorry, who has actually provided an interactive session on how location platform would evolve in 5G and how location becomes very important in the 5G and era. Yeah? And then Rahul spoke about the service evolution and his learning outcomes. Parvati also spoke about the way she learned the system design in 5G. Thank you one and all to the students. It was very lovely having you. Thank you for taking out your busy time in your semester end on contributing to this. I hand over to you, Danesh, thanking you for putting this session together with Sai and others' help there. Yeah.
Yes, thank you all. So we have one more symposium arranged by our department. It's on the World Environmental Day, June 5. It's called International Symposium on IoT and ML for Ecosystem Restoration and Multi-Hazard Resilience, ISIM 2021. So it is organized by Amrita Vishwavidyapitham, UNESCO Chair on Experiential Learning for Sustainable Innovation and Development, Amrita School for Sustainable Development, and Amrita Center for Wireless Networks and Applications. So there are some exciting programs waiting for you, such as hackathon and then PhD colloquium, poster sessions for researchers, and those who are interested, you can register in the link that you already provided in the chat. Okay, so thank you everyone for joining this wonderful webinar. Thanks to everyone. Thank you.
Thank you. Thanks, everyone. So can we close the the session?
One more thing, sir. Sir, you can just close the YouTube session over there because you are the host now. Streaming on that top.
I have not joined the YouTube, but do I need to go there or?
No. It's from the Zoom itself.
On the Zoom itself, okay. So I just end the session, it closes, right? Do I need to stop somewhere else?
Yeah, YouTube you need to end this. On the top left, I think, there is a live on YouTube is going on. Or you can just pass the control to me. I will manage it.
Okay, good. Thank you, Ganesh. I just don't see that, but I will just say more. Change. Make host. Yeah, I'm making you the host. Yeah. Okay, then I have passed.